Chapter 5 in 10th standard maths is areas related to circles. So in daily life we can see many objects which are in circular form, like for example wheel, as you see in the text. There's a washer, that's also in circular form. The plates are circular form. The wheel here again in this cart. So there are so many circular objects. So it's very important to know uh, basic concepts of circle, such as area, perimeter, and so on. So let us see what is there here. Perimeter and area of circle, a review. So what is perimeter and area? Perimeter and area. See, already you have studied about the perimeter of squares, rectangle, and all. What's the perimeter of square? So suppose if the square has side 1 centimeter, 1 centimeter, 1 centimeter, 1 centimeter. So the perimeter is 1 plus 1 plus 1 plus 1 is equal to 4. So 4 is the perimeter of this square. Similarly, what is the perimeter of triangle? Suppose if sides of this triangle is 1, 2 and 3 units. So perimeter will be 1 plus 2 plus 3. Okay. So now when it comes to circle also has some perimeter. So how to find that perimeter? So before understanding how to find perimeter, so let us understand the ratio of circumference by diameter. Now you know in a circle there's a diameter which passes through the center, and diameter is twice the radius, right? Diameter is equal to 2 times of radius, and circumference is this length. Okay, circumference or the perimeter. Now if you take one circle, say suppose there's a circle, small circle like this, okay, and there is diameter. Let us say circumference of this circle is C1, that is length. Suppose if I start from this point and if I measure the length, and I go like this here, that is the circumference. So let diameter be d1. Now if I take the ratio of c1 by d1, I'll get 3.1416. okay. Now if I take a bigger circle like this, say the diameter is big like this, let it be d2, and let the circumference, the length of the lateral edge, okay, let that be c2. Now if I take the ratio here, c2 by d1, again I'll get 3.1416. so no matter what the size of the circle, the ratio of circumference to the diameter will be a constant. That is, circumference by diameter of any circle will be a constant, that is 3.1416, and this is denoted by pi. The value of pi is equal to 3.1416. Actually the value of pi doesn't stop here itself. It doesn't stop at 3.1416. It's a recurring decimal. It's a non-recurring decimal, and it keeps on going, but will restrict it to 3.1416 for calculation purpose. Okay, and this value is also approximated to 22 by 7. So it's approximately equal to 22 by 7. You can read the textbook. In textbook there are some points regarding this, and one Indian scientist, Aryabhatta, had given the value of pi as 3.1416. Now, having known this value of pi, having known the concept of c by d, circumference by diameter, now we'll calculate the area of the circle. Now consider one circle of radius r. Now what I will do is, I will divide this circle into many equal parts. Okay, I'll divide like this. And let the circumference of this circle, circumference is the length of the curved edge. Okay, this is C. Now after cutting this circle like this, I'll arrange those cut pieces this way. Each piece is like a cone, and here it is a little curved. Next piece I'll arrange upside down this way, and next piece I'll put it in this way. So I go on continuing in this fashion. So until all the pieces are completed, I keep on arranging this way. See, if I make a very large number of pieces, there won't be curved edge only here. See, here in the bottom there's a little bit of curved edge, right? So if I make a very large number of pieces, this edge will be very smooth. Okay, also this upper edge also, it will be very smooth if I make a large number of pieces. And you can observe that this length, the top length will be half of the circumference, and even the bottom will be the same, half the circumference, and the breadth will be radius, length of the will be equal to the length of the radius. Okay, now this is almost like a rectangle now, where breadth is r and length is c by 2. Now what is the area of this rectangle? Area is given by length into breadth, so length is c by 2 into r. Now in the previous page we already learned that c by d, the ratio of circumference to the diameter, is a constant, and which is equal to pi. Now we'll cross multiply. C is equal to pi into d. So C is equal to pi. D is also equal to 2 times of r, that is 2 into r. So C is equal to 2 pi r. So I'll substitute that one. C is equal to 2 pi r divided by 2 into r. This 2 will get cancelled. So area of a circle is given by pi r square. There are some solved examples here. You can read. Everything is self-explanatory. So you should make a habit of reading a max textbook also. I'll go for exercise problem, exercise 5.1. Question number 1. The radii of two circles are 19 centimeter and 9 centimeter respectively. Find the radius of the circle which has circumference equal to the sum of the circumference of the two circles. So pi, the value of pi is 22/7. So first circle has radius 9 centimeter. There is another circle radius of 19 centimeter. So R1 is equal to 9 centimeter. So what is area of the first circle? No, sorry, we are not bothered about area, we are bothered about circumference. So circumference is given by 2 pi r1 for the first circle. So c1 is equal to 2 pi r1. So 2 pi r1 is 9 into 9. So 2 9s are 18 pi. Circumference of the first circle is 18 pi. So for the second circle, r2 is equal to 19 centimeter. Therefore circumference will be equal to c2, 2 pi r2. So 2 pi, so here it is 19 into 19. So this is 38 pi. So circumference of first circle is 18 pi. Circumference of the second circle is 38 pi. So what we want to find the radius of the circle which has circumference equal to the sum of the circumference of the two circles. Now what is c1 plus c2? C1 plus c2 is equal to 18 pi plus 38 pi. So this is 8 is 16, carry 1, 3, 4, 5, 56. Okay, c1 plus c2 is 56 pi. Now they want find the radius of the circle which has circumference equal to the sum of the circumference of the two circles. So they want radius of another circle, say r3, and this one should be equal to the sum of the circumference of the first two circles. That means 56 pi. So 56 pi. No, sorry, they want the circumference of the new circle to be c1 plus c2. So this they want to be as 56 pi. 56 pi. So they want circumference equal to 56 pi and find the radius of this new circle they are asking. So c3 is equal to 2 pi r3. So c3 we know it is 56 pi. 56 pi is equal to 2 pi r3 we don't know into r3. So pi will get cancelled. Now 2 1s are 2 2s are 4, 2 8s are 16. So r3 is equal to 28 centimeter. Question number 2. The radii of two circles are 8 centimeter and 6 centimeter respectively. Find the radius of the circle having area equal to the sum of the areas of the two circles. So there are two circles. Radius of one is 6 centimeter. Say it is r1, and there is another circle of radius 6 centimeter. So r1 is equal to 6 centimeter. So what is area of the first circle a1? So area is given by pi r square. So pi into 6 square. So 36, 6 6 are 36 pi. Area of first circle is 36 pi. This is 36 pi. And area of the second circle is given by pi r2 square. So here r2 is 8 pi. So this is 8 centimeter. So pi r2 is 8 square. So it is the 64 pi. Sorry, this is A2. Now they want another circle whose area is equal to sum of these two circle. So, sum of the areas of these two circle. That is, they want another circle A3, another circle whose area is A3, which is equal to A1 plus A2. So 36 pi plus 64 pi 98, this is 100 pi. So 100 pi. So A3 is 100 pi, and they are asking the radius. This the area of this new circle is 100 pi. What is the radius of this new circle? Now area is equal to pi, A3 is equal to pi R3 square. Now pi A3 we already know, it's 100 pi. R3 we don't know, that's what we need to find out. So 100 pi is equal to pi R3 square. So pi will get cancelled. R3 is equal to R3 square is equal to 100, or R is equal to square root of 100, or R is square root of 100 is 10, or R3. So the area of the new circle the radius of the new circle whose area is pi r 100 pi r will be 10 centimeter. Question number 3. In figure 5.3 depicts an archery target marked with its 5 scoring regions from the center outwards as gold, red, blue, black and white. The diameter of the region representing gold score is 21 centimeter. So the region of this gold is 21 centimeter, and each of the other bands are 10.5 centimeter wide. Find the area of each of the 5 scoring region. So, and every band is 10.5 centimeter. I am marking here. You can see it's 10.5. It's 10.5. It's 10.5. Now, what is the radius of the gold region? See, if this is the center, see, radius of the gold is 21 divided by 2, diameter divided by 2, it's 10.5. So R1 is, if I take the area of R1 as radius of the gold region, R1 is 10.5, that is 21 by 2. Okay. Next, what is R2? R2 is the radius of this circle. So R2 is 10.5 plus 10.5. Now what is R3? R3 is, this is R2. R3 will be equal to 10.5 plus 10.5 plus 10.5, 3 times 10.5. Now R4 will be 4 times of 10.5, or I'll write 10.5 into 4, or you can do addition also, it's left to you. Next, what is R5? That is R5 will be 10.5 into 5 times, or you can add 10.5 5 times, all this same only. Now we should find the area of each of the region. Now what is the area of gold region? So area of gold, so area is given by pi r1 square. Here r1 is the radius of the gold region. So this is pi is 22 by 7, and r is 10.5 the whole square. This, if you evaluate, you will get I'll write one more step further, 22 by 7 into 10.5 into 10.5. This you evaluate, you will get 346.5 centimeter square. Okay, area of the gold will be gold gold region will be 346.5 centimeter square. You evaluate this one and check it out. Now what will be the area of the blue band red band region? Area of red band region will be equal to, now this is will be equal to pi r2 square minus area of gold. So we need to find the only the area of the band. After gold we need to find the area of only the red band, blue band, black band and white band and so on. So my area of red band will be pi r2 square. Only pi r2 square will be the area of the region for which r2 is the radius. That's why I'll subtract with the area of the gold, so that I'll get only the area of the red band. So this, now here it will be pi, what is r2 here? R2 is 10.5 plus 10.5, that is 21. So 21 square minus area of gold. Area of gold is 346.5. So here 22 by 7, 21 square is 21 into 21 minus 346.5. You can evaluate and check this. You will get 1039.5 centimeter square. This is area of red region. Similarly, area of blue region will be area of blue region will be equal to pi r3 square minus area of gold region plus area of red region, because only I should find the area of the band, not the area of the circle for which r3 is the radius. So here 22 by 7, r3 is, now r3 is 10.5 plus 10.5 plus 10.5, it is 31.5. So 31.5 into 31.5 minus area of gold is 346.5 plus area of red region is 1039.5. So this you will get 1732.5 centimeter square. So please evaluate and cross verify with the answer. Now what will be the area of black region? Area of black region will be pi r4 square. Pi r4 square is the circle for which r4 is the radius. That area you will get. So to find the area of band only, you need to subtract with the area of gold and area of red region and area of blue region. Okay, now this will be 22 by 7. Now r4 is 10.5 into 4, so 42. So 22 by 7 into 42 into 42 minus area of gold. Area of gold is 346.5. Area of red region will be 1039.5 plus area of blue region is 1732.5. You add all these things and then you subtract with this result. So Now this you will get 2425.5 centimeter square, that is area of black. You evaluate and cross verify. Similarly, you can find the area of the black band, white band region, that's left to you. Question number 4. The wheels of a car are of diameter 80 centimeter each. How many complete revolutions does each wheel make in 10 minutes when the car is traveling at a speed of 66 km per hour? So the diameter of the car wheel is 80 centimeter. So this is the diameter, 80 centimeter. So D is equal to 80 centimeters. So what is the circumference? Circumference is equal to pi into D, pi D. So pi is 22 by 7, pi is 22 by 7. So D is 80 into 80. So circumference is equal to 22 by 7 into 80 centimeter. So what is the meaning of circumference? Circumference is nothing but the length of this curved edge. Okay, if you take a tape and if you measure, you will get 22 by 7 into 80 centimeter. Now suppose if this wheel starting at this point, if it makes one revolution, what is the distance it will travel? Actually it will travel a distance equal to its circumference. Starting at this point, if I push this wheel, and if the wheel makes one revolution, it will be traveling 22 by 7 into 80 centimeter. Again if it makes another revolution, it will further travel another 22 by 7 into 80. This is 7. Again if it makes another revolution, the wheel will travel another 22 by 7 into 80 centimeter. Okay. Now given that the speed of the car is equal to 66 km per hour. So 66 km per hour, that means in 1 hour it will travel 66 km. So 1 hour means 60 minutes, right? So in 60 minutes it will travel a distance of 66 km. So for 10 minutes how much it will travel? For 10 minutes it will travel 10 into 66 by 60. It's a simple cross multiplication, this with this. Okay, so 10 into 60 into 66. Now 6 to 0 0 will get cancelled. 6 1s are 6, 6 1s are 6, so 11. So in 10 minutes it will travel 11 kilometers. Now I already explained you that for a distance of 22 by 7 into 80 centimeter, the wheel will make one revolution or one spin, whatever you may say. And now to travel 11 kilometers, how many revolution will it make? Did you understand? To travel a distance of 22 by 7 into 80 centimeter, the wheel will make one revolution. So to travel 11 kilometers, how many revolution will it make? So here also the simple cross multiplication, this is called a unitary method. So this will be now equal to 11 11 kilometer into 1 revolution divided by 22 by 7 into 80. I'll take this as x and I'll rewrite so that you can understand nicely. Now cross multiplication, x into 22 by 7 into 80 is equal to 11 kilometer into 1 revolution. Now 11 kilometer, okay, 11 kilometer. Now x is equal to, again I'll cross multiply, 11 kilometer into 1 is 1 only, 11 kilometer. Okay, I'll put that 1 also as it is. Now this 7 will go in the numerator, and in the denominator I'll get 22 into 80. Now what is 1 kilometer, 11 kilometer in centimeter? See, 11, 1 kilometer is 1000 meter. I'll write in place of k, it is 1000. 1k is 1000. And what is meter? 1 meter is equal to 1000 centimeter. So in place of m, I am writing 100. So into 1 into 7 divided by 22 into 80. Now if you evaluate this, you will get 4375 revolution. That is to travel a distance of 11 kilometer, the car, the wheel of the car will make 4375 revolution. Question number 5. Tick the correct answer in the following and justify your choice. If the perimeter and the area of a circle are numerically equal, then the radius of the circle is. So what is perimeter? Perimeter is the length of this curved edge. So curved edge is also the circumference. So perimeter is equal to circumference. And what is circumference is given by, formula of circumference is 2 pi r or pi d, both are same. And what is the area given by? Area is given by pi r square. Now in the question they have told that the area is equal to perimeter, numerically equal to perimeter. So perimeter, so C is equal to A. If C is equal to A, what is the radius? That's the question. So what is C? C is equal to 2 pi r. What is A? A is equal to pi r square. Now this pi will get cancelled both in the left and right hand side. R also, 1 r will get cancelled. Now in the left hand side 2 is remaining, right hand side r is there. So if r is equal to 2 units, then the perimeter and area will be numerically equal. So correct answer is 5A. Next topic in a textbook is areas of sectors and segments of a circle. Areas of sectors and segments of circle. So you already know that the area of a circle is given by A is equal to pi r square. That means if this is the circle, pi r square is the total area. This area is pi r square. Now consider one circle and consider this portion. I'll draw two radius like this. This is r, this is r, let this be O, let this be A, let this be B, and APB is the arc. Okay, and now this portion is called the minor sector. Okay, this portion is minor sector, this is major sector. Sector is covered by two radius and an arc. This is minor sector. So whenever we are talking about sector, by default it's understood that it's minor sector only, unless otherwise it is specified. Now what is the area of this minor sector? See, whole area, if the what is the angle of a circle, it's what is the angle covered by the circle? The circle will cover an angle of 360 degree, right? So for 360 degree angle, the circle makes an area of pi r square. Pi r square is the area of the circle. So suppose this minor circle, this minor sector, if it makes an angle of theta, okay, so for theta degree, what is the area? So here simply it's a unitary method, you cross multiply. So for theta degree, the area will be theta into pi r square by 360. So this area is given by theta by 360 into pi r square, where theta is the angle of the minor sector. So similarly, in a circle, if theta is the angle made by the minor sector, this is the theta. So this arc APB, it has got some length, right? It has got some length here, and the whole circle has length 2 pi r. So circle makes covers an angle of 360 degree. So 360 degree, for 360 degree angle, the perimeter is C, that is 2 pi r. So for theta degree, what is the length of the arc? So that will be theta by 360 into 2 pi r. So if theta is the angle of the sector, then the arc length, that is APB, this arc length is given by theta by 60 into 2 pi r, and 2 pi r is the perimeter of the circle, 2 pi r. Now we'll learn about a segment. See, if this is a circle at centered O, and if there is a chord like this AB, and now this portion is called as minor segment. So minor segment is the area of the portion occupied by chord and the arc, the minor arc. This is major arc, major segment. So when segment word is specified, by default it's assumed that they are talking about minor segment only, unless it is mentioned as major segment. Now we know the area of a circle is given by pi r square. Area is equal to pi r square. And if there is a sector sector in it, as shown here, OAPB. Now this is the OAPB is the sector, right, and which is making an angle of theta degree. Now the area of the sector is given by theta by 360 into pi r square. I just explained this in the previous page. Now what about the area of this segment? Now I'll join A and B. Now AB is the chord, and now this portion is minor segment. Okay. Now what will be the area of this minor segment? Area of the segment APB. So it's minor segment. So area of segment APB is given by area of sector OAPB minus area of sector OAPB minus area of triangle OAB minus area of triangle OAB. So now area of sector OAPB, what is that? That is theta by 360 into pi r square. Now what is the area of triangle OAB? Sorry, minus triangle area of triangle OAB. Okay, I'll leave it here. Area of segment APB, of minor segment APB, is given by theta by 360 into pi r square minus area of triangle OAB. Now after learning all this, we'll solve some problems. See, till now whatever theory I have explained, it's there in the textbook. You can read. There are some worked examples also. You can go through it. All are self-explanatory. Now exercise 5.2, I'll be solving only exercise problems. Problem 1, find the area of a sector of a circle with radius 6 cm if angle of the sector is 60 degree. So pi we should take as 22/7. So there's a sector in the circle and the angle in the sector is 60 degree, and given radius is 6 cm. So 360 degree makes an area of pi r square. So pi r square, therefore 60 degree makes an area of 60 by 360 into pi r square. Therefore area of sector is equal to 60 by 360 into pi. What is r? R is given as 6 into 6 r square. So 0 will get cancelled. 6 1s are 6, 6 are 36. Now this 6 will get cancelled with this 6. So 6 pi is 6 pi centimeter square. Since the radius is centimeter, area will be in centimeter square. Second question, find the area of a quadrant of a circle whose circumference is 22 centimeter. So this is the circle and circumference is given as 22 centimeter. So quadrant means if I divide the circle into 4 equal parts like this, and this is the center. Then this portion is quadrant. So each quadrant has an angle of 90 degree. So here also, now you can directly use the formula. area of sector is equal to theta by 360 into pi r square. So many students will not be able to remember simple formula like this also. So that's why you can go for unitary method. 360 degree makes an area of pi r square. So theta degree makes an area of cross multiplication here. You will get theta by 360 into pi r square. That is the formula for the area of sector. Okay. So area of sector is the area of the quadrant here. So here the quadrant makes an angle of 90 degree by 360 degree into pi. What is r? So r, so given c is equal to 22, c is equal to 2 pi r, right? So c is 22 is equal to 2 pi into r, 2 pi r. So 2 ones are 2, 2 ones are 2, 2 ones are 2. So r is equal to 11 by pi. R is equal to 11 by pi. So substitute that one here into 11 by pi the whole square. So 90 by 360 degree into pi into 11 by pi into 11 by pi. So this pi will get cancelled with this pi. Sorry, this one 11 by pi. So 9 ones are 9, 9 fours are 36. So 1 by 4 into numerator, how much is left? 11 into 11 by pi. So evaluate this. I'll substitute the value of pi also. 1 by 4 into 11 into 11 by pi is 22 by 7. So 1 by 4 into 11 into 11. So here 22 by 7, it will become 7 by 22. Okay. Now 11 ones are 11, 11 twos are 22. So 11 into 7 is 77. 77 by 4 twos are 8 centimeter square. So area of the sector is, area of quadrant is 77 by 8 centimeters square. So let us see the answers. So answer exercise 5.2, second question, 77 by 8 centimeter square. Our answer is correct. Question number 3, the length of the minute hand of a clock is 14 centimeter. Find the area swept by the minute hand in 5 minutes. So the minute hand length is 14 centimeter. So if minute hand comes here, when it sweeps 5 minutes, okay, what's the area? This area they are asking. Okay, now r is equal to 14 centimeter. Therefore what is the area? Area is equal to pi r square. So area is equal to, pi is given as 22 by 7 into 14 into 14. 7 ones are 7, 7 twos are 14. So I'll keep this as it is. Now see, for 60 minutes, it sweeps an area of 22 into 2 into 14 centimeter square. Okay, this is the area. Therefore, for 5 minutes, what's the area it sweeps? So we'll adopt a unitary method, that is, we'll cross multiply. So what is the area? So let us say this is x. So x into 60 is equal to 22 into 2 into 14 into 5. Therefore x is equal to 22 into 2 into 14 into 5 by 60. Now 5 ones are 5, 5 ones are 5, 5 twos are 10. Then again 2 ones are 2, 2 ones are 2, 2 6 are 12. Then 2 threes are 6, 2 sevens are 14. Now this is equal to 22 into 7 by 3. Now here 22 into 7, 7 twos are 14, carry 1, 7 twos are 14 plus 1 15, 15 by 3, so x centimeter square. So the area swept by the minute hand after 5 minutes is 154 by 3 centimeter square. Fourth question. A chord of a circle of radius 10 centimeter subtends a right angle at the center. Find the area of the corresponding minor segment, major segment. Use pi is equal to 3.14. So here again pi is equal to 3.14. So there is a chord to a circle, and the radius of the circle is 10 centimeter. See, the chord is like this, and it is making an angle of 90 degree like this at the center. So it is given in the question itself. Okay, a chord of a circle of radius 10 centimeter subtends a right angle at the center. That means this AB, chord AB is subtending an angle of 90 degree at the center. This is O. Now find the area of the corresponding minor segment. So this is the minor segment. So I'll write this AP, and let this APB is the minor segment, AQB is the major segment. So major segment is this area. So radius, we know radius of the circle is R. R is equal to 10 centimeter. Therefore area of the whole circle is pi r square. So pi is, it is given as 3.14 into r square is 10 into 10. So this becomes 314 centimeter square. Okay, now first we'll find the area of the sector OAPB. So area of sector OAPB. So this sector has an angle of 90 degree. Okay, therefore the formula for that is theta by 360 into area. So what is theta? Theta is 90. So 360 into area is 314. So 0 will get cancelled. 9 ones are 9, 9 fours are 36. So now check whether this is divisible. I'll divide by 2 first. 2 twos are 4, 2 ones are 2, 2 fives are 10, 2 sevens are 14. Okay, now again so this is 157 by 2. Again it's divide by 2. 5 sevens of 2 sevens of 14. Then 2 6 are 2 8 are 16, 2 5 point, okay, 78.5. So area of sector OAPB is 78.5 centimeter square. Now area of segment APB will be equal to area of sector OAPB minus area of triangle ABC. Check the diagram. Area of triangle OAB. Area of segment APB is equal to area of sector OAPB minus area of OAB. Please check the diagram. So area of sector OAPB I got as 78.5. Now what is the area of triangle OAB? Half base into height, half into base. So we know radius is 10 centimeter. So height also is the radius here. So 10 centimeter. So how much I will get? So 78.5 here. 2 ones are 2, 2 5s are 10, 5 10s are 50, minus 50. So 78 minus 50 is equal to 28.5. So area of the segment APB is 28.5 centimeter square. Now what is the area of the major segment? See major segment makes an angle of 360 degree. There you can see, I'm redrawing again. See, this is the minor segment which has made an angle of 90 degree. So and the major segment makes an angle of 270 degree. So area of major segment, so area of major segment OAQB. So this is given by 270 by 360 into pi r square. So in pi r square we already know. So this is 27 by 360. So pi r square we already evaluated. It came 314. Now 2 9s are 18. Sorry, 3 9s are 27. 3 1s are 3. 3 2s are 6. Then again it is divisible. 3 3s are 9. 3 4s are 12. So this is 3 into 3 14 by 4. So evaluate this. Here again it's divisible by 2. 2 2s are 4. 2 1s are 2. 2 5s are 10. 2 7s are 14. Now 157 into 3. 3 7s are 21. 3 5s are 15. 16 17. 3 1s are 3 plus 1 4. So 471 divided by 2. So 2 2s are 4. 2 3 2 6 2 3s are 6. Then 2 5s are 10.5. So area of major segment OAQB is 235.5 centimeter square. Question number 5. In a circle of radius 21 centimeter, an arc subtends an angle of 60 degree at the center. So if this is the circle, so what is the arc? So this a part of the circumference is the arc. So there is an arc like this on the circumference. Let us say AB. So AB is the arc. So and the arc subtends an angle of 60 degree at the center, and given that radius is 10 centimeter. Sorry, radius is 21 centimeter. find the area of the corresponding minor segment. So minor segment is this one. So what is the area of the minor segment? So area of minor segment, area of I'll take this P, area of minor segment OAPB is equal to theta by 360 into 2 pi r, where 2 pi r is the area. So here theta is 60, so 60 by 360 into 2 pi r. So many people will not be able to remember this formula also. It's very easy to derive. 360 degree makes sorry, this is pi r square. So 360 degree makes an area of pi r square. Therefore 60 degree makes how much? Cross multiply. So you will get 60 by 360 into pi r square. So here 6 1s are 0 0 will get cancelled. 6 1s are 6, 6 6 are 36. 1 by 6. What is pi? Pi we should take 22 by 7 into 22 by 7 into r. R is 21. 21 into 21. So again now here you can divide in 3. 3 2s are 6, 3 7s are 21. This 7 will get cancelled. I am getting 22 into 21 by 2. This 2 1s are 2, 2 1s are 2, 2 1s are 2. So 11 into 22, 11 into 21. So 21 into 11, 21, 21. So 1 3. 231. So 231 centimeter square. Area of sector OAPB is 231 centimeter square. So this is the answer for the second sub question, area of the sector formed. Okay. Now what is the area of the what is the area of the major segment here? So I'll take this arc as Q. Now area of sector OBQA, area of sector OBQA is equal to, again you can use the formula. Now out of 360, 60 is gone, I'll get 300. So I'll write the formula itself. Theta by 360 into pi r square. So this is equal to, theta is now 300. So this major sector forms an angle of 300 by 360 into pi is 22 by 7 into r is 21 square. So 21 into 21. Now 7 1s are 7, 7 3s are 21. Here 0 0 will get cancelled. Then 6 5s are 30, 6 6 are 36. Again 2 3s are 6, 2 1s are 2, 2 1s are 2. Then this 3 will get cancelled with this 3. So I'm left with 5 into 11 into 21. So 11 into 21 already I know it's 231. 231 into 5. So what is 231 into 5? 231 into 5. So 5 1s are 5, 5 3s are 15, 5 2s are 10, plus 1 11. So 1 1 5, double 1 double 5. So double 1 double 5 centimeter square is the area of the major sector OBQA. Oh, this was not at all asked in the question. First sub question was the length of arc and the area of the segment formed by the corresponding chord. But it's okay. if you are asked in the examination, you can solve in this way. So arc length is given by formula theta by 360 into 2 pi r. So if you can't remember, it's very easy. 360 degree makes arc length of 2 pi r, that is circumference, also perimeter. Therefore theta degree makes arc length of what? So you can cross multiply, you will get theta by 360 into 2 pi r. This is how you can derive the formula if you can't remember. So theta, we know it's 60 degree, 60 by 360 into 2, pi is 22 by 7, 22 by 7 into r is 21. So 21, 0 0 will get cancelled, 7 1s are 1, 7 3s are 21, 6 1s are 6, 6 6 are 36. Now this is now again 3 1s are 3, 3 2s are 6, 2 2 will get cancelled. So I'll get 22 centimeter is the arc length. Arc length, that is arc length means ABP, okay, length of APB. So this is the first sub question in 5th main, and second sub question already we have solved. And in the third sub question, what they have asked, the area of the segment formed by the corresponding chord. I'll write a bigger diagram so that it can be understood properly. So now the chord AB is making an angle of 60 degree at the center, right? This way, this is 60 degree chord AB. Now there is a segment here. This area is the segment. So now area of the segment APB is given by area of sector OAPB minus area of triangle OAB. Now area of sector OAPB, we already found it. It turned out to be 231 centimeter square. So 231 minus what is area of triangle OAB? Now you can see that OAB is a right angled triangle. So I'll write that here. Sorry, OAB is a equilateral triangle. So here it is 60, here 21 centimeter. So here also it will be 60, here also it will be 60. So if two sides are equal and the included angle is equal to 60 degree, then that will be an equilateral triangle. So in equilateral triangle, the altitude bisects the side equally. So I am drawing the altitude here, let it be D. So it divides OA into equal two equal parts, that is OD is equal to OA. Therefore OD will be 21 by 2 and DA will be 21 by 2, or it's 10.5. Now what is AD? AD is now here square of the hypotenuse is equal to sum of the square of the other two sides. There are two right angled triangles here. So now AD square will be is equal to hypotenuse is OB square. So AD square is equal to OB square minus OD square. So OB square is 21 square minus OD square. OD square is 10.5 the whole square. I'll keep this 10 instead of 10.5 I'll keep it as 21 by 2 only. So this is 21 square minus 21 to the whole square. For the sake of simplicity I am doing this. Therefore AD square is equal to 21 square minus, so 21 square by 2 square. So this is equal to LCM. Now it is 4. So 21 square, 4 minus 1 I'll get. Therefore AD will be is equal to square root of this thing, square root of 20 square root of 21 square by 4. 4 minus 1 is 3 into 3. So AD will be is equal to 21 root 3 by 4. Now I'll substitute that one here. Now area of triangle OAB, area of triangle OAB is equal to half base into height. Half base is 21. You can see in the diagram. Base is OA, that is 21, into height. Height is 21 root 3 by 4. So sorry, this is 2. 21 root 3 by 2. 21 root 3 by 2. Now this is equal to 231 minus. So 21 into 21, I'll get 441 into root 3. 2 into 2 is 4. So this many centimeter square is the area of the segment APB. That completes this problem. Exercise 5.2, question number 6. So a chord of circle of radius 15 centimeters subtends an angle of 60 degree at the center. Find the area of the corresponding minor and major segment of the circle. So there is a circle and there is a chord. Let us say the chord is AB. So the chord, it is subtending an angle of 60 degree at the center, like this. So I'll call this chord AB. Center I'll call as O. So what we need to find the area of the corresponding minor and major segment. So this is the minor segment. So minor segment is A. I'll call this D. ADB is the minor segment, and major segment is BEA. Okay. Now what is the area of the minor segments? Area of minor segment ADB is given by area of the circle minus area of segment, area of sector OBEA, area of sector OBEA minus area of triangle OAB. So what is the area of circle? So area of circle is pi r square. So pi into radius is given as 15 centimeter. So OA and OB will be 15. So pi into 15 pi r square is r square means 15 square. So 15 into 15 minus what is the area of OB, area of sector OBEA. So here the major sector forms an angle of 300 degree. Minor segment is 60 degree. Therefore major segment will form an angle of 360 minus 60, that is 360 degree. So what is the formula for the area of the sector? Is given by theta by 360 into pi r square will be the area of sector. Okay, I'll use this formula. Here theta is 300. Sorry, the minor sector makes an angle of 300. So 300 by 360. 360 is the area of the 360 is the angle of the circle into pi r square. So pi into r is 15 into 15. Okay, minus area of triangle OAB. So here half base into height. So before proceeding we should find the height of the triangle. See, I'll draw the triangle OAB. So this is a equilateral triangle. Sides are 15 centimeter and angle is 60. Therefore this angle also will be 60, this angle also will be 60. OAB. So here what is the altitude? So altitude will be is equal to square root of, so altitude makes an angle of 90 degree to the base. Therefore this is a right angle triangle. I'll mark this CF. Okay, OFB is a right angle triangle. Therefore square of the hypotenuse is equal to sum of the square of the other two sides. Therefore altitude BF square will be square root of hypotenuse square, OB square minus OF square. So this is equal to OB is 15. So 15 square minus OF will be half of OA, since this is a equilateral triangle. Therefore here it is 15 by 2 the whole square. So what will I get here? So 15 square minus 15 square by 2 square here in the denominator. So 15 square I can write as 15 by 1. So here 15 square by 1 minus 15 square by 2 2s are 4. So again if I take 4 as LCM, so 4. So here in the numerator 4 into 15 will come. 4 into 15 square minus 15 square root. So here in the numerator I'll take 15 square common. 15 square 4 minus 1, the denominator 4 as it is. So here, so square root of 15 so square root of 15 square is 15 square 15, and square root of 4 is 2. So into 4 minus 1 3, that root 3 will be as it is. So 15 by 2 root 3 I will get. So substitute the base and altitude here. So here area of triangle OIB is equal to half base. Base is 15 centimeter. 15 height is, just now we found out, it is 15 by 2 into root 3. Now what they are told to substitute the value of pi as 3.14. So I'll substitute 3.14 into 15 minus, so here 0 will get cancelled. 3 10s are 30, 3 12s are 36. So 10 by 12. Again I can divide. 2 5s are 10, 2 6s are 12. So 5 by 6. 5 by 6 into pi is 3.14 into 15 minus 1 by 2. So here 1 by 2 into 1 by 2, 1 by 4. 1 by 4 into 15 into 15. So root 3 they are told to take as 1.73. So instead of root 3 I'll put 1.73. So this if I evaluate, I'll get here first term 706.5. Next I'll get 588.75 minus 97.3125, and totally I'll get 20.4375 centimeter square. So area of the minor segment ABD is equal to 20.4375 centimeter square. Now what is the area of the major segment? So now area of major segment, so here major segment is BEA. So this is given by area of circle minus area of minor segment. Area of minor segment ABD. Just now area of minor segment we got as 20.4375. So area of circle also we know it is 706.5. So 706.5 minus 20.4375. So this is equal to 686.0625 centimeter square. So at the end I've skipped this calculation. You can calculate and verify. Let us verify the answer. So exercise 5.2, answer is 20.4375, first one, and the second one is 686.0625. Exercise 5.2, question number 7. A chord of circle of radius 12 cm subtends an angle of 180 degree at the center. Find the area of the corresponding segment of the circle. So there's a circle and there is a chord to the circle such that the chord subtends an angle of 120 degree at the center, this way 120. So I'll call the chord as AB, and radius is given as 12 centimeter. So OA is equal to 12, OB is also equal to 12, and I'll call the segment as ADB. ADB is the segment, and I should find the area of this one. This area, this marked area I should find. Now what is the area of that segment given by? So area of segment ADB is equal to, I'll take the area of whole circle and subtract from that the not this whole circle, I'll take the area of the sector OADB, and I'll subtract from it the area of triangle OAB. So area of sector OADB. So area of sector OADB minus area of triangle BOA. So if I subtract like this, I'll get the area of segment ABD. Okay, now what is the area of sector OADB given as? So formula is theta by 360 into pi r square gives the area of sector OADB minus what is the area of triangle BOA, is that is given by half base into height. Base is 12, so height we don't know, I'll put as h. So here theta is 360, so sector makes an angle of theta is 120, sector makes an angle of 120 degree at the center. So 120 by 360 into pi, they have told to take as 3.14 into r is 12, 12 into 12 minus coming to the area of the area of the triangle, half base is 12, height we don't know. So how to find height? If I get the height, I'll get the solution. So to find the height, what I'll do is I'll extend OA in the reverse direction this way. So now what is the angle? I'll extend and such that it will touch the other end of the other end at the circumference. So I'll call that E. Now what is the length of EO? EO is also 12 centimeter. So EO also is 12 centimeter. Now from B I'll draw one altitude. So altitude means it will make an angle of 90 degree. So what is angle BOE now? Angle BOE is 60 degree. So why it is 60 degree? EOA is a straight line and BOA is 120 degree. So 180 minus 120, 60 degree. So now I'll join B and D also. Now BEO is a BEO is a equilateral triangle. Okay, EO is 12 and BO is also 12, and that included angle is 60 degree. Therefore BEO is a equilateral triangle. I am writing it again here. BEO is an equilateral triangle. So all sides are in an equilateral triangle, all sides are equal and all angles are equal. Now so I have drawn an altitude, say that is BF. Now what is the length of BF? BF is nothing but the altitude. Okay, and this altitude of this triangle is also the altitude of triangle BOA, because EA is a straight line and both these triangles are standing or on this line, so both have common altitude. So now what is BF is equal to? BF is equal to square root of BO square minus FO square. So here BFO is a right angle triangle, therefore square of the hypotenuse is equal to sum of the other two sides, sum of the square of the other two sides. So BO square will be equal to BF square minus FO square, or BF is equal to square root of BO square minus FO square. So what is BO? BO is 12 square. What is FO? See, FO is 12 by 2. In an equilateral triangle, altitude divides the base into two equal parts. So it is 12 by 2, the whole square. So this is square root of 12 square minus this 12 square and 2 square. So 12 square means 12 square by 1. So square root of 12 square, I'll take LCM. LCM, I'll get 4. That means 2 square minus 12 square by 2 square. I've taken LCM. So now here 12 square into 2 square is 4 into 4 by 2 square. So 12 square by 2 square. Now 2 square I'll take common in the denominator. So in the numerator 12 square. So 12 square is common, so 4 minus 1. So again I'll get this as 12 square. 4 minus 1 is 3. So 12 into root 3. 12 into 3 by 2 square. So now in the denominator, the square root and this 2 will get cancelled. In the denominator, I'll get 2. And in the numerator, 12 square root of 12 square is 12 only. 12 into root 3. So this is the altitude BF. Also this is the altitude of triangle BOA. Now I will substitute this altitude here. 120 by 360. So here I will simplify. 0 0 will get cancelled. 12 ones are 1, 12 3s are 36, 3 ones are 3, 3 4s are 12. So I am left with 3.14 into 4 into 12 minus 1 by 2. So here also I can simplify 2. Okay, 12 into height. Now I just now found height is 12 by 2. 12 by 2 into root 3. So here 2 ones are 2, 2 6 are 12, 2 ones are 2, 2 6 are 12. So I am left with 3.14 into 4 into 12 minus 6 into 30 is root 3. So this I'll get 150 minus 7 2, this 62.28. So this arithmetic calculation I am skipping. You please do it and cross verify. So finally I'll get 88.44 centimeter square. The area of the segment ADB is equal to 88.44 centimeter square. The next problem in exercise 5.2 is problem number 8. A horse is tied to a peg at one corner of a square shaped grass field of side 15 meter by means of a 5 meter long rope. Find the area of that part of the field in which the horse can graze. So this is a ground of 15 meter length each side, 15 and 15. So the horse is tied and that rope is of 5 meter length. Okay, so that horse can graze this much of area. This is 5 meter. So find the area of that part of the field in which the horse can graze. So this area first I should find, that is in part 1 sub question. So now you can see that this angle is 90 degree here, because this is a square shaped grass field, square shaped grass field. So here it is 90 degree. Therefore what is the formula of this sector? I'll name this as OADE. So area of sector OADE is given by 90 by 360 into pi r square. Pi they told to take 3 point, okay, pi into r square. So 90 by 360 is equal to pi is 3.14 into r is 5 into 5. So for those people who can't remember this formula, area of sector formula, see 360 degree gives an area of pi r square. Therefore for theta degree, how much? So it's simple cross multiplication. So theta into pi r square by 360. This is formula. If you can't remember, you can derive by your own. It's very simple. So this is 360 here. So here 0 0 will get cancelled. 9 1s are 9, 9 4s are 36. Then again, can you divide by 2? Yeah, you can divide. 2 2s are 4, 2 1s are 2, 2 5s are 10, and 2 7s are 14. So 1.57. So I'm left with 1.57 into 5 into 5 divided by 2. 1.57 into 5 into 5 by 2. So this turns out to be 78.5 centimeter square. Cross verify. Now what is the second sub question? So now the length of the rope is increased from 5 meter to 10 meter long, and they are asking the increase in the grazing area if the rope were 10 meters long instead of 5 meter. Okay, now if the rope is increased another 5 meters, so this will be the area the horse can graze. So I'll mark this like this. This area I should find. So so let this be OP, Q and R be the new sector formed. Okay, now area of OPQR, area of sector OPQR is given by, now here also the angle remains the same. So 90 by 360 into pi r square, so 90 by 360 into pi is 3.14, r now it is 10 into 10. So here 0 0 will get cancelled. 9 1s are 9, 9 4s are 36, 2 2s are 4, 2 1s are 2, 2 5s are 10, 2 7s are 14, 3.15. Again 2 1s are 2, 2 5s are 10. So I'll get 1.57 into 5 into 10. So this turns out to be 19.625. So please cross check. Now I want only the extra area that has been formed. So this is 1 and this is 2. So the increase in grazing area will be 1 minus 2. Increase in grazing area is 1 minus 2. That is, this is equal to 78.5 minus 19.625. So this is centimeter square. So I'll get 58.875 centimeter square. So wherever area is in question, the unit will be centimeter square or meter square or kilometer square. You should know that the dimension of an area will be in meters, centimeters like that, but area will be in centimeter square, meter square like that. If in a square the sides are like this, the length will be like in meters or centimeter, area will be, the unit of area will be in meter square like this, meter square. So you need to mention this centimeter square. If you don't mention, they may deduct half mark or 1 mark. Question number 9. A brooch is made with silver wire in the form of a circle with diameter 35 millimeter. The wire is also used in making 5 diameters which divide the circle into 10 equal sectors as shown in the figure. Find the total length of the wire required, the area of each sector of the brooch. So now using a wire they have made a brooch. Brooch means first they have made a circle, and they have made 5 diameters like this. This is first diameter, second diameter, this is third diameter, fourth and fifth diameter. So using a wire, they have using a silver wire they have made this so called brooch. So I should find the length of the wire. So length of the wire, so total length of the silver wire is equal to the circumference of the circle, that is pi into d, and 5 times the diameter. So they have made 5 diameters, right? So each diameter is of length 35 millimeter. So the total length of the wire will be the length of the circumference plus 5 times the diameter, 5 times into d. So this is 22 by 7 into d is 35 plus 5 into d is 35. So 5 ones are 5, 5 7 7 ones are 7, and 5s are 35. So 22 into 11 is 110 plus 175 I will get here. So total 285. So the length of the silver wire required is 285 millimeter, and total number of brooch is brooch is equal to 10. Sorry, total number of sector is 10. So you can see in the figure there are 10 sectors formed in the brooch, and I should find the area of each sector. So the area of the circle divided by 10 will give area of each sector. There is no need to find the angle itself. So area of each brooch is equal to area of the circle pi r square divided by 10. This millimeters I'll get. So pi is 22 by 7 into r. So diameter is 35. So radius will be half of that, 35 by 2. So this pi r square by 10. So this will be 22 by 7 into 35 by 2 into 35 by 2 divided by 10. 7 ones are 7, 7 5s are 35. Again 2 ones are 2, 2 ones are 2, 2 ones are 2. So I'll be left. Now this 10 is 10 by 1. Okay, I can take that 10 by 1 to the numerator. So 11 into 5 into 35 by 2. So if I take 10 by 1 in the numerator, it will be reciprocal of that. So it becomes 1 by 10. Now 5 ones are 5, 5 2s are 10. So now I'll get in the numerator 11 into 35, 385 I'll get, 2 2s are 4. This many millimeters square is the area of each sector of the brooch. The next question in exercise 5.2 is question number 10. An umbrella has 8 tips which are equally spaced as figure 5.13. Assuming umbrella to be a flat circle of radius 45 centimeter, find the area between the two consecutive ribs of the umbrella. So umbrella is like this. So there are 8 ribs. 1, 2, 3, 4, 5, 6, 7 and 8 ribs. So they're asking us to assume that this umbrella to be a flat circle of radius 45 centimeter. That means this is 45. Each rib is of 45 centimeter length. Find the area between the two consecutive ribs. That means I should find the area of this one sector. So now angle is not known, so it's not necessary also to know it. So I can find the total area of the circle and divide by 8, because 8 ribs makes 8 sectors here. So the total area of the circle divided by 8 gives the area of each sector. There's no need to find angle itself. So area of each rib is equal to area of each sector, right? Area of each sector. So area of each sector is equal to total area of the circle divided by 2. So there's no need to use this formula 360 degree into pi by r square. This is the formula for area of the sector. There's no need to use that. So you can directly divide by 8. So here pi r square divided by 8. So what is pi? Pi 22 by 7 and r is 45. 45 into 45 divided by 8. So here 8 means 8 by 1. So I can take in the numerator. So I'll get 22 by 7 into 45 into 45 into 1 by 8. 45 means it's 45 by 1. Okay. Now 2 ones are 2, 2 ones are 2, 2 fours are 8. So in the denominator 7 fours are 28, and in the numerator 45 into 45 you will get to the triple 275. So this many centimeter square is the area. So arithmetic calculation you do it by yourself. So in the answer it's given answer is 22275 by 28 centimeter square. So arithmetic calculation at the end I have skipped. You do it by yourself. The next question is question number 11. A car has two wipers which do not overlap. Each wiper has a blade of length 25 centimeters sweeping through an angle of 115 degree. Find the total area cleaned at each sweep of the blades. So in car, okay, in car glass, upon the car glass there will be wipers. You know that there will be two wipers. Okay. So and they wipe and they make an angle of 115 degree, 115 degree. So there are actually two wipers. Okay. Now what is the area of the area cleaned by the wiper? That's the question. So now I'll draw a bigger sector like this. Okay, these are the wipers. So each wiper is making 150 degree, 150 degree. So if I complete a circle like this, okay, and the length of the wiper is given as 25 centimeter. This is 25 centimeter. Okay. Now I should find the area of this sector. So 2 times the area of this sector gives the total area cleaned by the wiper. Okay. So total area cleaned by the wiper is equal to, here there are two sectors, so 2 times, okay, area of each sector, 2 times into area of each sector, okay. So this is equal to 2 into, what is the area of each sector, what is the formula, that is theta by 360 into pi r square. Oh yeah, I think the circle didn't come properly, I'm redrawing it. I think you can see now. So theta by 360 into pi r square, pi is 22 by 7. So first I'll write the formula itself, pi r square. So 2 times theta is 115 by 360, so pi is 22 by 7 into r, so r is 25 into 25, so this is equal to 2 times of, so here you can divide by 5, 5 2s are 10, 5 3s are 15, 5 7s are 35, then 5 2s are 10, so now you can divide by 2, 2 3s are 6, 2 6 are 12, 2 1s are 2, 2 1s are 2, so I'm left with 22 into 11 into 25 into 25, here in the denominator 36, 11 by 7, so 36 into 7, I'll get 252, and in the numerator you will get 158125. You do the arithmetic calculation and check it out, this will be the answer. This many, how much, what is the unit, centimeters, so the length was given as centimeter, so the area will be centimeter square. Another 2 is left out here, so 2 into this much, so this 2 will, 2 1s are 2, 2 1s are 2, 2 2s are 4, 2 6 are 12, so 15812 divided by 126 centimeter square is the answer. Question number 12. To warn ships for underwater rocks, a lighthouse spreads a red colored light over a sector of angle 80 degrees to a distance of 16.5 km. Find the area of the sea over which the ship are warned. So in seashore, there is danger of ships hitting the rocks at the bottom, okay. So this is the ship, okay, and there is, to avoid that, see here there may be rocks like this in at the bottom, okay, or something like this rock. There is danger of a ship hitting the rock, so there is some kind of arrangement in the seashore. There is something called lighthouse, and here they're emitting light, some red color light at an angle of 80 degree like this. So at 80 degree angle, some red light is coming, so maybe this by this red light the rocks at the bottom are visible, or some arrangement is there like that, so that the ship they are positioned, or they are driven such that it won't hit the rock. Such arrangement it is there, so they are finding now. We should find the area, this area I should find, whatever light comes. So what is the area covered by this light beam, that one we should find out, okay. So now area will be area of the sector formed by the light beam, so area is given by theta by 360 into pi r square. So theta we know it is 80 degree. So 80 by 360 degree into pi. Pi, have they given pi? They are told to use 3.14, and the distance, that is the radius, here it is 16.5, the whole square. So 80 by 360 into 3.14 into 16.5 into 16.5. So here 0 0 will get cancelled. 8 2 4 are 8, 2 18s are 16. Now 4 2 2s are 4, 2 9s are 18. So I'm left with 2 into 3.14 into 16.5 into 16.5 by 9. So here ultimately you will get 189.97 centimeter. Is it centimeter? No, it's kilometer square. Kilometer square. This is the area of the area by the light covered. So the length was given in kilometer, therefore the area will be kilometer square. Next question is question number 13. A round table cover has 6 equal designs as shown in figure 12.14. The radius of the cover is 28 centimeter. Find the cost of making the design at the rate of rupees 0.35 per centimeter square. Use root 3 is equal to 1.7. So there is some table, and so a cover is put on that and design is made at the border area like this. So okay, I'll name this one A, B, C, D, E and F, and they've given the radius of the cover is 28 centimeter. That is this radius. This is 28 centimeter. 28. This is also 28. And the design is at the border like this. Only these are the design. So what is the cost of the design they are asking? If the cost per centimeter square is 0.35 rupees. So what I should do is I should find the total area of this design, and then I should proceed to calculate the cost. So and see here, what is this angle AOB. See here there are totally 1 2 3 4 5 6 design is there. That means there are 6 sectors like this. There are 6 sectors. So what is the angle of each sector? It will be 360 by 60. So I'll write angle made by each sector is equal to 360 by 6. So 6 6 are 36. So it will be 60 degree angle made by each sector. Now what is the area of one segment? For example, what is the area of segment APB? Area of segment APB will be equal to area of sector OAPB minus area of triangle OAB. So that gives the area of each segment. And what will be the total area? total area will be 6 times of this, because there are 6 segments. Okay, so total area will be equal to 6 times into area of each segment. Area of each segment is equal to, I'll put this one here. So area of each segment is area of each sector minus area of triangle OAB. So all triangles are similar only here. So area of each sector or area of sector, I'll write OAPB. So here all the sector are similar to one another and all the triangles are also similar to one another. So total area will be 6 times into area of each sector minus area of each triangle. Now this is equal to 6 times into area of each sector will be theta by 360 into pi r square. This is the formula. And area of area of OAB. Now here 6 by 6 into theta. Now each sector is making an angle of 60 degrees. 60 by 360 into pi. They are told to assume how much. They have not mentioned anything, so pi will be 22 by 7 only into r square. So r is 28 into 28. Now coming to area of OAB. Area of triangle OAB is given by half base into height. Half base into height. Now what is base and height in triangle OAB? So see, I'll draw the triangle OAB here. OAB is an equilateral triangle. Okay, and the side is 28 centimeter. Each side is 28, and each angle is 60. So if two sides are equal and their included angle is 60, then that triangle will be a equilateral triangle. Therefore here OAB is a equilateral triangle, because OA is 28, OB is 28, and the angle between them is 60. So it's an equilateral triangle. So from here, base is 28 centimeter, and what is the height? Height is this one. Say I'll name it as L. Okay, so BL is the height. See, height, altitude makes an angle of 90 degree to the base. Therefore OBL is a right angle triangle. Okay, now square of the now apply the Pythagoras theorem here. Square of the hypotenuse is equal to sum of the square of the other two sides. Therefore OB square is equal to OL square plus BL square. So this is 28 square is equal to OL is half of the base, that will be 28 by 2. So 28 by 2 the whole square plus BL square. Now I'll bring this to the left hand side. 28 square minus 28 square by 2 square is equal to BL square. Therefore BL will be square root of this much. So therefore BL will be square root of, I'll take square root of both the sides. Therefore in the right hand side that power of 2 will go. So 28 square minus 28 square by 2 square. So 28 square means it is 28 square by 1. So here I'll take LCM. So 28 square into, so here 4 is the LCM, or 2 square by 2 square minus 2 square, 28 square by 2 square. So 2 square is the LCM. Therefore in the left part I'll multiply and divide by 2. This is equal to BL. So 2 square I'll take common, 2 square. So in the numerator 28 square, so and 28 square is common, so 28 and 2 square minus 1 is the will be left. Square root of this much is equal to BL. Now again 28 square, so 2 square is 4, 4 minus 1 by 2 square is equal to BL. Again I'll get 28 square, 4 minus 1 is 3, I'll put it as it is, 2 square is equal to BL. So now square root of 2 square is 2 only. In the denominator I'll get 2, and in the numerator square root of 28 square is 28 only, so I'll be left with only root 3. So BL will be 28 by 2 into root 3, or simply in an equilateral triangle the altitude will be root 3 times of the base. Now here what is this 28 by 2? What is base? Base is 28. So root 3 by 2 times into base. Base is 28. So this is true in any equilateral triangle. Altitude will be equal to root 3 by 2 into base. Now I'll substitute this value here. So here 6. So 60 by 360 into 22 by 7 into 28 into 28 minus half. Base of this triangle OAB is 28, and altitude we just now found out, it's root 3 times. I'll substitute here root 3 by 2 into base. This is the altitude. Now you simplify, 0 will get cancelled, 6 1s are 6, 6 6 are 36. Now again here 2. Okay, now I'll open the bracket. Okay, if I open the bracket, this 6 will get multiplied to first term. This is the first term, this is the second term. So 6 into, so here I'm left with 1 by 6 into 22 by 7 into 28 into 28 minus, so 6 I should multiply to the second term also, 6 into 1 by 2 into 28 into root 3 by 2 into 28. So here 6 will get cancelled, so I'm left with 22 by 7 into 28 into 28 minus, so here I'll make some more simplification. 2 1s are 2, 2 1s are 2, 2 4s are 8, 2 1s are 2, 2 1s are 2, 2 4s are 8. I'm left with 6 into 14 into root 3. They have told to take it as 1.7. So root 3 I'll take 1.7 into 14. So here in the left in the first term I'll get 2464, and in the second term I'll get 1999.2. So finally I'll get 464.8 centimeter square. So this is the area of all the segments, so, area of all the 6 minor segments. Now given cost is equal to rupees 0.35 per centimeter square. So that means for 1 centimeter square the cost is 0.35 rupees. Therefore for 464.8 centimeter square, what is the cost? So it's simple cross multiplication. So it will be 464.8 into 0.35 into 1. So this turns out to be 162.68 rupees. This is the final answer. So arithmetic calculation, it's left to you. Please cross verify. Exercise 5.2, question number 14. Tick the correct answer in the following. The area of sector of angle P of circle with radius R is. So we already know that area of sector is given by the formula theta by 360 into pi r square, okay, where r is the radius of the circle. So here this is the formula. For those of few people who can't remember this simple formula also, it's very easy to derive. See, in a circle makes an angle of 360 total, right? So what is the area of the circle is given by pi r square. So 360 degree angle makes an area of pi r square. Therefore theta degree makes an angle of, you can cross multiply, this is unitary method. So theta into pi r square by 360, cross multiplication. So this is the formula for area of the sector, which I have written here. Very easy to derive. So here the given that angle is p degree. So in place of theta I'll write p. So p by 360 into pi. So in place of r is capital R they have given. So I'll write that r square. So p by 360 into pi into r square. Now I'll multiply both numerator and denominator by 2. Effectively it makes no changes in the equation. So by multiply by numerator by 2, denominator also by 2. So pi means pi by 1, r square is r square by 1. There shouldn't be any confusion. So now see now in the denominator 360 into 1 into 2. So how much I'll get? That will be 720. So in the numerator p. So 2 as it is, pi and r square. So p by 720 into 2 pi r square is the area of this sector. And that completes this exercise. So the choice is D. The next topic in this chapter is areas of combination of plane figures. See, it's very easy. You know the formula for area of triangle. You know the formula of area of square. What is the formula for area of triangle? The area of triangle is half base into height. Half base into height. This is base. This is height. Similarly, what is the area of this square of side S? So area is equal to side into side is the area. So what is the formula for area of rectangle of length L and breadth B? So here area is equal to length into breadth is the area. Now suppose if the figure is like this, one square and above there's a triangle. So what is the area here? So here the area will be area of this square plus area of this triangle. If you add both the area, you will get the area of the whole figure. So similarly, now we'll come across some figures where we need to calculate areas, and the figures will be complex figures. As in this example, you can see example 4. See here, you can see there's a square and there are two perimeters. So what is the area of this whole figure? We should, or the area of the whole figure will be area of the square plus area of this top perimeter which is at the top, and area of the perimeter which is at the bottom. So I think in this question they have asked to calculate the area of only the colored region, whatever it is. So you go through the problems, all will be easy, all are self-explanatory. Now in see in example 5, they have asked to find the area of the colored region here. So area of the colored region will be the area of the square minus the area of the four circles there. And in the next question we should find the area of the colored region here. Go to the text, it's all easy self-explanatory. I'll directly go and solve some example problem. Now exercise 5.3, question number 1. Question number 1, find the area of the shaded region in figure 5.19 if PQ is equal to 24 centimeter and PR is equal to 7 centimeter and O is the center of the circle. So figure is like this. There's a circle and diameter QR, and there's one chord. This is PQ. PQ is a chord. So they are told that PR is equal to 7 centimeter. Sorry, PQ is equal to 24 centimeter and PR is 7 centimeter. Okay. Now find the area of the shaded region. This area I should find. Now in a what is the angle subtended by the diameter on the circumference? What is this angle? RPQ. So RPQ will be equal to 90 degree, because in any circle the diameter will subtend an angle of 90 degree at the circumference. Okay, this you have learnt in a previous chapter. Now what is the length of QR? See now QPR is a right angle triangle, therefore QR will be square of the hypotenuse will be equal to the sum of the square of the other two sides. Therefore here QR square is equal to PR square plus PQ square. So this is equal to PR square is equal to PR square is 7 square plus PQ is 24 square. PQ square is 24 square. So this is equal to 7 7 is 49. 24 into 24 is 576. So sum of these two, 9 plus 6 15, carry 1 7 8 9 10 11 12, carry 1 5 plus 1 6. So QR square is equal to 625. Therefore QR will be equal to square root of 625. Square root of 625 is 25. So QR is equal to 25. Therefore OQ will be half of this. OQ is the radius. So OQ will be 25 by 2 and OR also will be 25 by 2. Now what is the area of the shaded region? Now the diagonal divides this circle into two equal parts, right? Therefore there are two semicircles here. So now I'll write the area of shaded region. Now there is one semicircle there, that is OR PQ is one semicircle there. Okay, what is the area of that? It will be the half of the area of the circle. What is the area of the circle? Pi r square. So pi r square is the area of the whole circle, and if I divide that area into 2, I'll get the area of the perimeter. So pi r square by 2 minus area of the circle, area of the triangle, area of the triangle R RPQ. This gives the area of the shaded region. So pi I'll substitute here, 22 by 7 into R is 25, 25 by 2, 25 by 2 into 25 by 2. So this gives the area of the square. Divide by 2 gives the area of the semicircle. Okay, minus area of triangle RPQ is equal to half base into height. So here base, if I take as 7, height will be 24. So both are given in the data itself. So this becomes, see if we can simplify. So in the denominator 2 is there. 2 means it is 2 by 1. Okay, so I'll take that to the numerator. It will so in the numerator it becomes the reciprocal. 2 by 1 becomes 1 by 2. 1 by 2 into 22 by 7 into 22 by 25 by 2 into 25 by 2 minus 1 by 2 into base into height. This is 7 into 24. I'll keep it as it is. So here 2 ones are 2, 2 ones are 2, 2 ones are 2. So I'm left with 11 by 7 into 25 by 2 into 25 by 2 minus 1 by 2 into 7 into 24. So in the first part, 11 into 25 into 25, I'll get 6875 by 7 into 2, 7 into 2 into 2 is 28, 28 minus, so here 1 by 2 into 7 into 24. So you take 28 as the LCM, 28. So 6875 minus, so here it becomes 1 into 7 into 24 into 14. So I'll get 6875 minus 2450 by 28. So ultimately I'll get 4425 by 28 centimeter whole square is the area of the shaded region. So arithmetic calculation I have skipped a bit, that's left to you. So this is 2352 and ultimately you get 4423 by 28 centimeter square. We'll go to next problem. Next problem in this exercise, find the area of the shaded region in figure 5.20 if the radii of the two concentric circles with center O and 7 centimeter are 7 centimeter and 40 centimeter respectively, and angle AOC is 40 degree. So this is the circle, two concentric circles are there, and there are two sectors which are overlapping on one another. So O is the common center for both the circles, and the sector has an angle of 40 degree. So A, this is C, B, D. I should find the area of this one, shaded region. Okay, and the radius of the inner circle is 7 centimeter, and the radius of the outer circle is 14 centimeter. So what I'll do is I'll find the first find the radius of the outer the bigger sector, which is the bigger sector here. OAC is the bigger sector, and after that I'll find the area of the smaller sector, that is OBD. OBD is the smaller sector. So I'll find the area separately, and if I take the difference of these two areas, I'll get the area of the shaded region. I'll add some more letters here. D, this is E. I'll take this as F, this arch. Okay, now area is the difference of between these two sectors. So area is equal to, what is the formula of a area of a sector? That is given by theta by 360 into pi r square. So here area is equal to, area of the shaded region is equal to area of the bigger sector is area of OAEC, area of sector OAEC minus area of sector OBFD. Okay, now what is the area of sector OAEC? So it is making an angle of 40 degrees. So 40 by 360 into pi. R is 14. The radius of the outer circle is 14. So 14 square minus area of the smaller sector OBFD is here also it is making an angle of 40 degrees, this smaller sector. So 40 by 360 into pi, and here R is 7, so 7 square. So here I can so pi we need to take 24 by 7 if it is not mentioned. Here I will simplify. This 0 will get cancelled. 4 1s are 4, 4 9s are 36. Here also same thing, 4 will get cancelled. 4 1s are 4, 4 9s are 36. So I am left with 1 by 9. I will substitute pi. Pi is equal to 22 by 7. And 14 square, I will write 14 into 14 minus. Here 1 by 9 is left. Pi is 22 by 7 into 7 into 7. So to make this calculation simple, I'll take 1 by 9 into 22 by 7 as common. So 14 into 14 minus 7 into 7 is left out. So here 1 by 9 into 22 by 7. So here 196, 14 square is 196, 7 into 7 is 49. So 1 by 9 into 22 by 7. So 196 minus 49. 196 minus 49. 16 minus 9 is 7. Then 8 minus 4 is 5. So 8 minus 4 is 4. 4 and this one as it is. So into 147. Now see whether you can further simplify. So yes, I can further simplify. 7 1s are 7, 7 2s are 14, 7 3s are 27. It's 21 here. And now 3 3s are 9, 3 7s are 21. So I'll get 22 into 7 by 3. So this turns out to be 7 2s are 14, 7 2s are 14 plus 1 15. So 154 by 3 centimeters square is the answer. That is the area of the shaded region. So the radius were in centimeter, so the area will be in centimeter square. Exercise 5.3, question number 3. Find the area of the shaded region in figure 5.21 if ABCD is a square of side 14 centimeter and APD and BPC are semicircles. So this is a easy problem. So there is a square of side 14 centimeter. Each side is 14 centimeter. So ABCD is the square and there are two semicircles. APD is one semicircle and BP is the area of the another semicircle. So now I should find the shaded region. So to find the area of the shaded region, I'll subtract the area of these two perimeters formed from the area of the square. So area of this square is given by side into side, that is 14 into 14 centimeter. And what is the area of the semicircle? That will be, see now each semicircle makes an angle of 180 degree like this. This semicircle makes an angle of 180 degree. This semicircle makes an angle of 180 degree like this. So each area of each semicircle is 180 divided by 360 into pi r square. So area of shaded region is equal to area of the square, area of square ABCD minus area of these two semicircles. So there are two semicircles, so I'll write 2. So area of each semicircle is given by 180 degree by 360 degree into pi r square. Pi is 22 by 7 and r is, so here radius of each semicircle is 7, that is 14 by 2, 7 square. So area of square is equal to square ABCD is side into side, that is 14 into 14 minus 2 into area of area of semicircle. So area of semicircle 180 by 360 into 22 by 7 into 7 by 7 into 7. So what is the area of a sector? Area of sector is given by theta by 360 into pi r square. So in case of perimeter, theta will be 180 degree. That's why here it is 180 by 360 into 22 by 7 into 7 square. So 14 into 14 minus 2. So here I can simplify. 0 will get cancelled. 18 ones are 18, 18 twos are 36. Now 2 ones are 1, 2 ones are 1, 2 ones are 1. So here 7 will get cancelled. Here I am left with 2 into 11 into 7. So 14 into 14 minus, this is 2, 11 7 are 77. So 14 into 14, how much? So 14 into 14, 4 4s are 16, 4 1s are 4, 5, 1 4s are 4, 1 1s are 1, 6, 1 9, 1. So 196. So 2 7s are 14, 2 7s are 14 plus 1 15. So the subtraction now, 6 minus 4 is 2, 9 minus 5 is 4, 0. So 42. So 42 centimeters square. The area of the shaded region is 42 centimeters square. Exercise 5.3, question number 4. Find the area of the shaded region in figure 5.22, where a circular arc of radius 6 cm has been drawn with vertex O of an equilateral triangle OAB of side 12 cm. So there is an equilateral triangle of side 12 cm. So equilateral triangle is OAB, each side is 12 cm, and at point O one circle is drawn of radius 6 cm. So this length is 6 cm. Now there is also a sector here. Okay, this sector is common to this circle and this equilateral triangle. I will name this ODEF. Now we should find the area of this region. Now area of this region is given by area is equal to area of circle with centered with O as center, okay, plus area of triangle plus area of triangle OAB. But these two uh, this circle and equilateral triangle has sector common, ODEF as common between them, so I need to subtract that area of sector also here. So area of circle plus area of triangle OAB plus minus area of sector ODEF, and it's given in the question what is the area, what is the angle of that sector. This angle is 60 degree because since OAB is an equilateral triangle, all the angles will be equal to 60 degree. Therefore, the sector ODEF makes an angle of 60 degree. Now, what is the area of circle? Area of circle is given by pi r square, that is pi into r. R is, I'll write the formula itself first, pi r square plus what is the area of triangle OAB, that is half base into height. I'm writing just the formula. And what is the area of the sector ODEF, that is given by theta by 360 into pi r square. So here pi, I'll substitute the value of pi, 22 by 7 into r is 6 radius, okay, 6 square plus half into, here in triangle OAB base is 12 centimeter. What is the height? So we need to find the height. To find the height, I'll draw one perpendicular from O to the base, okay. So I'll call this as D. So in any equilateral triangle, the altitude or the median divides the base into two equal parts. Therefore, AD will be equal to 6 and DB will be equal to 6 centimeter. Okay, 6 centimeter or 12 by 2 centimeter. Now in triangle OAD, angle D is equal to 90 degree. Okay, therefore it's an equilateral triangle. OAD is an equilateral, sorry, OAD is an right angled triangle. Therefore, according to Pythagoras theorem, the square of the hypotenuse is equal to sum of the square of the other two sides. Therefore, here AO square is equal to AD square plus DO square. So AO is 12 square is equal to AD is 12 by 2. So AD will be half of the base. So 12 by 2 the whole square plus DO square is nothing but the height. I'll write as it is DO square. Now I'll bring this to the left hand side. 12 square minus 12 square by 2 square is equal to DO square. Now 12 square means it is 12 by 1 only. Okay, so 12 square, so 12 square by 1 minus 12 square by this 2 square is 4. I'm just simplifying, DO square. Now LCM of these two, LCM of 1 and 4 is 4. So in the left hand side first term it becomes 12 square into 4, 12 square by 1 into 4 by 4. It becomes like this, minus 12 square by 4 is equal to DO square. Now I'll take 4 common. So 12 square into 4 minus 12 square is equal to DO square. So in the numerator I'll take 12 square common. So 12 square into 4 minus 1. 12 square I'm taking common, divided by 4 is equal to DO square. Now again this becomes 12 square. 4 minus 1 is 3. 12 square into 3 by 4 is equal to do square, or do square is equal to square root of, or do is equal to square root of 12 square into 3 by 4. Okay, now what is the square root of 12 square? Square root of 12 square is 12 only, or I'll write one more step further. This will be like this: square root of 12 square into square root of 3 square, sorry, square root of 3 divided by square root of 4 is equal to do. So square root of 12 square is 12 only. Here the square root symbol and this 2 will get cancelled, so only 12 I'll get. 12 into root 3 divided by square root of 4 is 2, so is equal to do. So do is nothing but root 3 into 12 by 2. So I'll substitute that height. So do is nothing but height, so I'll substitute that height here. Area of triangle OAB is given by half base into height. Half base is AB 12, so height is 12 by 2 into root 3. 12 by 2 into root 3 minus, here in the area of the sector ODEF, theta is 40, sorry, theta is 60. The sector is making an angle of 60 degree, okay, by 360 into pi is 22 by 7. So R is 6 into 6 into 6. So I'll further simplify this. So 22 by 7 into 6 square is 6 into 6 plus 1 by 2 into 12 into 12 by 2 into root 3. So here I can 0 0 will get cancelled. 6 1 is 6, 6 6 is 36. So minus 1 by 6 into 22 into 6 into 6. So 22 by 7 here, sorry, 22 by 7. Now here there are 3 terms. One, this is first term, this is second term, this is third term. I'll write first and third term side by side. So this is equal to, okay, 22 by 7 into 6 into 6. So I'll write these two side by side, first and third term, minus 1 by 6 into 22 into 6 into 6. Third term I'll write at the end, plus 1 by 2 into 12 into 12 by 2 into root 3. Just for simplicity sake I'm mixing here, that's it. So now in these two you can see that I can take 22 by 7 into 6 by 6 as common. So 22 by 7 into 6 into 6 I'll take common, and here 1 minus 1 by 6 will be left, plus, now here I can simplify. 2 1s are 2, 2 6 are 12, 2 1s are 2, 2 6 are 12. So 6 into 6 is 36, 36 root 3. So now 22 by 7 into 6 into 6. Now here LCM I'll take as 6. So 6 minus 1 plus 36 root 3. Now if you simplify this one, you will get here 6 and 6 will get cancelled. So I'm left with 22 by 7 into 6. So 6 minus 1 is 5 plus 36 root 3. So now 22 into 6 into 5, I'll get 660 Please check it out. By 7 plus 36 root 3. This is what the answer given in the textbook. So answer. So in textbook you can see exercise 5.3, question number 4. Answer is 660 by 7 plus 36 root 3. And write the unit also, this many centimeter square. Next question is question number 5. From each corner of a square of side 4 cm, a quadrant of circle of radius 1 cm is cut, and also a circle of diameter 2 cm is cut as shown in the figure. Find the area of the remaining portion of the square. So that's a square. And what's the radius? Sorry, what's the side? Each side is 4 centimeter. 4 centimeter. 4 centimeter. 4 centimeter. And this is A, B, C, D. And inside there's a circle is cut, and the diameter is 2 centimeter. So diameter is 2 centimeter. And at the corners, quadrant, there are quadrant cut like this, and here the radius is it not quadrant? Yeah, this radius is 1 centimeter. 1 centimeter. 1 centimeter. 1 centimeter. So I should find the area of the shaded region. That's the question. Now you can see that the circle which is there inside, what is this area? Area is pi r square. So this area will be pi into r. So since the diameter is 2 centimeter, area will be pi r square, pi into 1 square. So this is the area of the circle which is there inside. And what is the area of the quadrant? For example, the area of this quadrant, will be 90 by 360, because a quadrant makes an angle of 90 degrees. Suppose if I complete this circle here like this, this portion is a quadrant and it is making an angle of 90 degree. So theta by 360 into pi r square is the area. So pi into r is 1. So pi into 1 square. So there are totally 4 quadrants in this figure. Okay. Therefore area is given by area of shaded region. This will be equal to area of the square minus area of the inner circle minus 4 times into square of 4 times into area of the quadrant. So area of square ABCD minus area of circle minus 4 times into area of quadrant. Okay. Now what is the area of the square ABCD? It is side into side. So it's 4 into 4. Side is 4 centimeter, right? So area of the square is 4 into 4 minus what is the area of the circle? That is pi r square. Pi into r square. R is 1. Pi into 1 square minus 4 into, so area of each quadrant is 90 by 360 into pi into R is 1, so into 1 square. So I will get 4 4s are 16 minus, I'll substitute the value of pi. Pi is 22 by 7 into 1 square is 1 only, minus 4. Now here I can simplify. 4 ones are 4, sorry, 0 0 will get cancelled. 9 ones are 9, 9 fours are 36. Okay, so I'll get 1 by 4 into pi. 1 square is 1 only, into 1. Okay, I'll substitute value of pi also here. 22 by 7 into 1. So this is equal to 16 minus 22 by 7 minus, so here this 4, okay, I'll write one more step further. 4 into 1 by 4 into 22 by 7 into 1. So 4 4 will get cancelled, so I'll be left with 16 minus 22 by 7 minus 22 by 7. So here 16 means 16 by 1. So now take the LCM. So if I take the LCM of 1 and 7 is 7 only. So 16 by 1 into 7 I'll get here in the first term, minus 22 by 7 minus 22 by 7. So what is 16 into 7? 6 6 are 36, 6 7 are 42. 4 carry, 7 1 are 7, 8 9 10 11. So 112 minus by 7 minus 22 by 7 minus 22 by 7. So I'll get in the numerator 112 minus 22 minus 22. So the final answer is 1. So 112 minus 44 by 7. 112 minus 44. Finally I'll get 68 by 7 centimeter square. This is the area of the shaded region. So question number 6, exercise 5.3. So in a circular table cover of radius 32 centimeter, a design is formed leaving an equilateral triangle ABC in the middle as shown in figure 5.2. For find the area of the design. So the triangle, there's a table and they put a cover on it, such that, and they made design on that cover as shown in the figure. The design is on the border side only. So these are the design. So and so it makes a equilateral triangle in the center ABC, and given the radius is 32 centimeter. So that means AO, so this is the center of the table. AO, BO and CO, all these are 32 centimeter in length. 32. So now I should find the area of the design. That means this area of the shaded region I should find. Now the area of the shaded region is given by area of shaded region or the design region. Okay, area of the shaded region is given by area of the circle minus area of the triangle. Area of circle minus area of triangle ABC. Now area of the circle, it's very easy to find. It's just simple, pi r square. So pi, so r is 32 square, minus what is the area of triangle ABC? This is half base into height. So half base is BC, height. So I'll draw the height. I'll extend AO it meets D at on BC. Okay, this is D. AO in B. So area of ABC, triangle ABC is half base into height, that is half BC into AD. BC into AD. Now we don't know BC, and we don't know AD also. So how to find this? So ABC is an equilateral triangle, that's given in the question itself. Therefore angle A is equal to B is equal to angle C is equal to 60 degree. Okay, ABC is an equilateral triangle. Therefore angle A is equal to angle B is equal to angle C. Angle A is equal to angle B is equal to angle C is equal to 60 degree. And also AB is equal to BC, sorry, side AB is equal to BC is equal to CA. Let us say it is A centimeter. Okay, or simply A. So in an equilateral triangle, the altitude bisects the base. Okay, so AD is perpendicular to BC. So AD bisects the base. That means BD is equal to DC. So they will be half of BC, that is A by 2. So we assume that AB is equal to A, BC is equal to A, and AC is equal to A. Therefore now BD will be equal to DC is equal to A by 2. So this will be A by 2. This will be equal to A by 2. In any equilateral triangle, the altitude bisects the base. Now ODC, angle ODC is equal to 90 degree. Now angle DCO is equal to 60 by 2, because OC is the angular bisector of angle C. Therefore we know angle C is 60 degree. Therefore DOC will be half of that, that is 60 by 2, that is equal to 30 degree. I'll mark that angle here, it is 30 degree. Now I'll use concepts of trigonometry here. In triangle ODC, okay, DC by OC is equal to cos 30. So this concept will come across in trigonometry. If you have not learnt, you may have already learnt, or even if you have not learnt, remember this. In any right angle triangle, adjacent by hypotenuse will be equal to cos theta, that is cos of the angle formed between adjacent and hypotenuse. Okay, so here in triangle ODC, DC is the adjacent side and OC is the hypotenuse side. Therefore DC by OC is equal to cos 30. So DC is A by 2, so half of the base A by 2, and OC we know that it is radius, that is 32 centimeter, and cos 30, the value of cos 30 is root 3 by 2. So just accept this fact, cos 30 is root 3 by 2. When you learn trigonometry in detail, you will come to know. Now what is A? Now I'll cross multiply. So A by 2 is equal to root 3 by 2 into 32. So here 2 will get cancelled. So A I'll get as 32 root 2. That A I'll get as 32 root 3. Now similarly I'll mark this as 1. Now similarly consider uh, triangle ADC. In triangle ADC, ADC is a right is a right angle. Therefore now here DC, not DC, AD by AC, that is opposite. AD is the opposite and AC is the adjacent side with respect to angle C. So this is equal to sine 60 or sine C, angle C. Okay, so AD we know that it is, no, AD we don't know. AD by AC is A. So sine C, so angle C is 60 degree. So this is equal to sine of 60 is root 3 by 2. So AD by A we know that it is 32 root 3, 32 root 3 from 1. Okay, from 1 we are taking this. Now if you cross multiply, you will get AD is equal to 32 root 3 into root 3 by 2. So this becomes 32. Root 3 into root 3 is 3 only, by 2. So 2 ones are 2, 2 6 are 2 ones are 2, 2 6 are 12. 13 into 6 is 48. So 48. So AD is equal to 48, which is equal to, okay, it's equal to 48. I'll leave it here. This is 2. Now coming to our solution, the area of shaded region is equal to area of circle minus area of triangle ABC. So area of circle is pi r square, that is pi into 32 square minus 1 by 2 into half base into height. Base is BC and height is AD. I'll substitute here. Now pi is 22 by 7 into 32 square, 32 into 32 minus half base is BC. So BC is nothing but equal to A. So A I found that it is 32 root 3. 32 root 3 and AD is the height. So AD I got as 48. From 1 and 2 I got this one. From 1 and 2 I substituted. Okay. Now area is equal to, so here see if you can simplify. 2 ones are 2, 2 ones are 2, 2 6 are 12. So 22 by 7 into 32 into 32 minus, so this is 16 into 48 into root 3. So you will get ultimately 22528 by 7 minus 768 root 3, this many centimeter square as the answer. Cross verify. In the textbook answer is given as exercise 5.3, question number 6. So it is 22528 by 7 minus 763 into root 3 centimeter square. The next question in this chapter is problem number 7. In figure 5.25, ABCD square of side 14 centimeter with centers A, B, C and D. 4 circles are drawn such that each circle touch externally 2 of the remaining 3 circles. Find the area of the shaded region. So there is a circle of side 14 centimeter each, and at each vertex the one circle is drawn such that all these circles they touch one another. I mean adjacent circles touch. Okay, so and this area is formed and we should find the area of this shaded region. That's the question. So A B C D is the square, side is 14 centimeter. So now the area of the shaded region is given by its, this is a very simple one. So area of shaded region is equal to area of square minus area of the four quadrants that is formed. Okay, area of square ABCD minus, now there are four quadrants here, so 4 times into area of each quadrant, area of each quadrant. So here all the quadrants are identical only, all the quadrants are similar, so that's why I'll take 4 into area of each quadrant. Now what is the area of square? Area of square is given by side into side, so each side is 14 centimeters, so side into side is the area, so 14 into 14 minus 4, area of each quadrant. Now you can see that you take any quadrant, you can see that the quadrant makes an angle of 90 degree. Okay, so 4 into, so what is the formula for a sector? It is given by theta by 360 into pi r square. Okay, where pi r square is the area of the circle. So now here theta is 90 degree, 90 degree by 360 degree into pi is 22 by 7 into r square. So r here it is 14 by 2, 14 by 2 is 7, alright, 14 by 2 only, 14 by 2 the whole square. Now you simplify, 14 into 14 minus 4, now here you can simplify, 0 will get cancelled, 9 ones are 9, 9 fours are 36. Now again 2 twos are 4, 2 ones are 2, 2 ones are 2, so 1 by 2 into 11 by 7 into 14 by 2 is 7, so 7 into 7, alright, so this 7 and this 7 will get cancelled, and now I'm left with 14 into 14 minus 4 into, I'll open the bracket, 4 into 1 by 2 into 11 by 1 into 7, now 2 ones are 2, 2 twos are 4, so 1, now 14 into 14 minus this 2 into 11 is 22, 22 into 7, 22 into 7, okay, I'll write 22 into 7, now 14 into 14 is 196 minus 22 into 7, 2 sevens are 14, 2 sevens are 14 plus 154, so 196 minus 154, 6 minus 4 is 2, 9 minus 5 is 4, 0. Okay, this many centimeter square. Area of the shaded region is 42 centimeters square. Exercise 5.3, question number 8. Figure 5.26 depicts a racing track whose left and right ends are semicircle. So the distance between two inner parallel lines segment is 60 meter and they are each 106 meter long. If the track is 10 meter wide, find the distance around the track along its inner edge, the area of the track. So this is the track and they are given the distance between the inner parallel line segment is 60 meter. That means everywhere it is 60, they are parallel. Okay, so and also they are given the length of this is 106. The distance between the two inner parallel lines segment is 60 and they are each 106 meter. This is 106 meter long, and here also it is 106 meter long. Now I should find the distance around the track along its inner edge. Okay, so there is inner edge and there is outer edge. What is the length of the inner edge I should find? So that means I should find the perimeter of the inner edge. Okay, so that is nothing but perimeter. So perimeter is nothing but the sum of all the sides. So here there are two sides, one side which is in the bottom and one side which is at the bottom. One is at the top and one is at the left and one is at the right. See, here in the left there is one curve. What is the length of the curve? That will be pi d by 2. See, in any circle the circumference is given by pi d or 2 pi r. So circumference is nothing but the perimeter of the circle. Okay, that is C. So pi d by 2 gives the perimeter of the semicircle here. So there is a semicircle formed on the left side, so that will be pi by 2. Similarly on the right side there is a semicircle here. So and the perimeter or the length of the curve on the right side, this is given by, again this is also pi d by 2. Just pi d gives the circumference, pi d by 2 gives the half of the circumference, that is the length of the curve of the semicircle. So here perimeter is given by, what is the top length, that is 106, bottom length is 106, plus left curve length is pi d by 2. I'll write like this only so that you can understand. This is left curve, plus right curve is also pi d by 2. This is right curve. Perimeter is nothing but the sum of all the sides, okay, of a closed figure. So here 106 is 6612, carry 1, 2, 1 plus 1, 2. So here pi is 20, so plus, this is plus, so 22 by 7 into d. D is nothing but 60 because the distance between the two inner lines are 60. So 22 by 7 into 60 divided by 2, plus in the fourth term also it is the same, pi is 22 by 7, d is 60, the whole divided by 2. Now 212 plus, now simplify this. So here 2 in the denominator, 2 is there, 2 means it is 2 by 1. If I take to the 2 to the numerator, it becomes 1 by 2. So 22 by 7 into 60 into 2 by 1 becomes 1 by 2 in the numerator, so 1 by 2, plus here 22 by 7 into 60, here also same thing, 2 means 2 by 1. I'll take to the numerator, it becomes 1 by 2. Now simplify, 2 1s are 2, 2 3s are 6, 2 1s are 2, 2 3s are 6. So here the first term is 212. 212 means 212 by 1. So you take LCM. Now I'll write one more step further, 212 by 1 plus 22 into 30 by 7 plus 22 into 30 by 7. So I'll take LCM as the common as the LCM, sorry, I'll take LCM of 1 and 7. So LCM of 1 and 7 is 7. So 212 into by 1 into 7 by 7 plus 22 into 30 by 7 plus 22 into 30 by 7. So you will get 212 into 7, 212 into 7, you will get 1484 plus 660. 22 into 30 will get 60, 660 plus 660 by 7 I'll get. So final answer you will get 2804 by 7 meter square. The distance, the length were in meters, therefore the the perimeter also will be in meters only. Okay, 2804 by 7 meter. Only in case of area we'll get meter square, centimeter square, that way, but in perimeter it is just meter. Now in the second part they've asked to find the area of the track. So track is like this. So now you can see there are two rectangles of length 106 and height is 10 centimeter. They have given the if the track is 10 meter wide, so track is 10 meter wide, everywhere it is 10 meter wide. Okay, so the rectangle at the top is 106 by 10. Okay, similarly at the bottom there is one more rectangle, that is 106 by 10. Okay, so what is the area of the top rectangle? It is 10 into 106. Length into area of a rectangle is length into breadth. So and here also at the bottom area is given by length into breadth, that is 10 into 106. Now what is the area of the band here on the left and the right side? Now you can see that there are two sectors here. Okay, first sector has a radius of 30, this is 30, and the second sector has radius 30 plus 1 40. So this distance is 60. Okay, the first sector has radius 30, second sector has the bigger sector as radius 40. So the area of this band is given by theta by 360 into pi r square minus theta by 360 into pi into r2 square. So first one I'll take r1 square, second one I'll take r2 square. Okay, so r1 is nothing but the bigger one, so theta by 360 into pi, r1 is the radius of the bigger sector, so that is 40 square minus theta by 360 into pi into r2 is the radius of the smaller sector, that is 30 square. Similarly, the area formed here in the right side, the band of the band region, where that region's area is given by theta by 360 into pi r1 square minus theta by 360 into pi r2 square. So what we are doing here, actually this portion gives the area of the bigger sector, big sector. So this portion gives the area of the small sector. So when we subtract this, we will get the area of this region. Okay, this band region. So now what is the total area of the track? Total area of the track will be total area of track is equal to area of the rectangular track formed at the top one, which you can see there. So that is 10 into 106 plus area of the track formed at the bottom, the area of the rectangular part, okay, which is there at the bottom. Again it is 10 into 106 plus the area of the circular band region formed at the left, that is theta by 60, theta by 360. Here you can see that the sector forms an angle of 180 degree. So here theta is 180, so 180 by 360, 360 into pi, pi is 22 by 7 into r1, r1 is 40, 40 whole square minus theta, again it is 180 by 360 into pi, 22 by 7 into pi, into r2 square, that is 40, 40 this whole square. Again I should add the same thing. Instead I will multiply into 2, because the left portion, the left curved portion and the right curved portion are similar to one another. So instead of adding once again, I will multiply into 2. Okay. So 10 into 106 is 1060 plus 1060. So here simplify this, 0 0 will get cancelled, 18 ones are 18, 18 twos are 36, 2 ones are 2, 2 11s are 22. Here also 0 0 will get cancelled, 18 ones are 18, 18 twos are 36, 2 ones are 2, 2 11s are 22. So I'll get 11 into 40, 40 square is 40 into 40, the denominator 7 minus 11 into, so here I have made one mistake, the length, the radius length of the smaller sector is 30, so 11 into 30 into 30 by 7 into 2. So here 1060 plus 1060, 0, I'll add these two terms, 2 to 6 plus 6 12, carry 1, 1 plus 1 2, so 2120 plus, now here 11 by 7 I will take common, 11 by 7, so I left with 40 into 40, 40 into 40 minus 30 into 30, sorry this is 11 by 7 into 2, so now 2120 plus 11 by 2, so this is 4 4s are 16, 1600, 3 3s are 9, 00 into 2, so here 2120 plus this 11 by 7, 11 by 7, so 1600 minus 900, I'll get 700 into 2, so 7 ones are 7, 7 ones are 7, 0 0, so I'll get 2120 plus 11 into 100 into 2, 2 11 are 22, 22 22 1 2200 I will get. So I'll add these two, 0 2 2 plus 1 3 4, so 4320 meter square is the area of the track. The next question in exercise 5.3 is question number 9. So in figure 5.27, AB and CD are two diameters of circle with center O perpendicular to each other. OD is the diameter of the smaller circle. If OA is equal to 7 centimeter, find the area of the shaded region. So this is a circle where AB and CD are the diameters, and diameters are perpendicular. That means they make an angle of 90 degree like this. Okay, and they are given the radius is 7 centimeter. OA is 7 centimeter. That means OB also is 7, OC also is 7, and OD also is 7. Now I should find the radius of area of the shaded region, this. Okay, so now what is the area of this inner circle here? This area will be pi r square. That means pi r square. So that is 22 by 7 into here OD is 7. So radius will be 7 by 2. D by 2 is the radius. So 7 by 2 the whole square. That is the area of this inner circle. And now what is the radius? What is the area of this segment? Okay, segment. Okay, BEC. What is the area of segment BEC? Area of this will be area of the sector. Okay, area of sector OCEB. So there are 4 sectors, and in sector OCEB there is a segment called BEC. Okay, so area of OEC, area of sector OECB minus area of triangle OBC gives the area of this segment. Okay, now the total area will be sum of this and this. So first let me find out the area of segment BEC itself. So this area will be theta by 360. Formula is theta by 360 into pi r square is the area of sector OCEB, and area of OBC, area of triangle OBC is half base into height, half. So base is OC and height is BO. So here theta is 90 degree. This sector is making an angle of 90 degree. So 90 by 360 into pi 22 by 7 plus R. R is how much? 7. Okay, 7 square. That is radius 7. Radius of the bigger circle minus half. Here OC is 7 and BO is also 7. Now total area will be sum of these two, sum of this one and sum these two. Okay, so I'll write area of shaded region. Area of shaded region is equal to 1 plus 2, which is equal to 22 by, so sorry, here this is 22 by 7. So 22 by 7 into 7 by 2 into 7 by 2 plus area of segment BEC. Area of segment BEC is 2. So that is 90 by 360 into 22 by 7 into 7 square. That is 7 into 7 minus 1 by 2 into 7 into 7. So simplify this. So here 7 ones are 7, 7 ones are 7. This to get cancelled. 2 ones are 2, 2 ones are 2, 2 ones are 2. So 11 into 7 by 2 I'll get in the first term. So in the second term 0 0 will get cancelled. 9 ones are 9, 9 fours are 36. Again 2 twos are 4, 2 ones are 2, 2 ones are 2. So here I'll get and this 7 will get cancelled. 7, this 7 and this 7 will get cancelled. So 11 into 7 by 2 minus, so here 1 by 2 into 7 into 7. have made one small mistake here. Here there are two segments, that is segment BEC, and another segment is there, so AFC. So and these two are similar, therefore here I'll multiply into 2 because there are two segments. Okay, so into 2 I'll do, so into 2, so here 77 by 2 plus, now this 2 will get cancelled, this will get cancelled, so this 2 should be multiplied for the second term as well as third term. This is the first term. If I open the bracket, this 2 will get multiplied to the second term and the third term also, so I'll be left with 11 into 7 minus 7 into 7, so 77 by 2 is 7, 2 3s are 6, then 2 3s are 6, 2 8s are 16, 2 5s are 10, so 11 into 7 is 77 minus 7 7 7s are 49, so I'll get final answer I'll get 65.5, and the unit is centimeter square. So area of the shaded region is 66.5 centimeter square. So I hope there's no confusion here. Here the shaded region is the area of this inner circle and plus the area of segment BEC and area of segment AFC, and both area of segment BEC and segment AFC are similar to one another. That's why I have multiplied by 2 here in this portion. I have multiplied by 2. Exercise 5.3, question number 10. The area of an equilateral triangle ABC is 17320.5 centimeter square. With each vertex of a triangle as center, a circle is drawn with radius equal to half the length of the side of the triangle. Find the area of the shaded region. Use pi is equal to 3.14 and root 3 is equal to 1.73205. So here there is a triangle ABC, and from each vertex they have drawn a circle, and these adjacent circles touch one another. Now we should find the shaded area region, area of the shaded area region. They have given the area of triangle ABC as 17320.5 centimeter square. So the area of the shaded region is area of the square, area of the triangle minus area of the sector formed there. Okay, so here there is one sector here, there is another sector here, and there is another sector here. So 3 sectors are there, and since this is an equilateral triangle, the all angles are equal to 60 degree. 60. So area of the shaded region, area of shaded region is equal to area of triangle, triangle ABC minus, so all the sectors are similar in this one, so 3 times into area of sector gives the area of the shaded region. Now area of triangle is already known, but what is the area of the sector? See here, to know the area of sector we need to know the radius. Radius is not given, so how to find radius? So what I'll do is, since this is an equilateral triangle, all sides are equal. I'll assume that they are equal to A. I'll assume BA is equal to A centimeter. Okay, BA is equal to A, AC is also equal to A. and BC also I will assume as A. So now here I'll make one more marking, A, B, C. This point I'll mark as P, this as Q, and this as R. So now BP, what is the B? I'll also join AP. Okay, I'll join AP. Now BP will be A by 2, and PC also will be A by 2. Why means in an equilateral triangle always the altitude bisect the base into two equal parts. Okay, so BP will be A by 2, PC will be A by 2. Now what is the area of triangle? Area of triangle is given by half base into height. Okay, area of triangle ABC is equal to half base is BC. What is the height? Height is AP. Okay, now area of the triangle, it is given as 17320.5. This is equal to 1 by 2 into BC I have taken as SA, and what is AP? AP will be root 3 by 2 times of base. So this will be AP. See how to derive this one. See, consider this triangle. In triangle ABP is a right angle triangle because altitude always makes an angle of 90 degree. So here applying the Pythagoras theorem, I will get square of the hypotenuse, that is BA square. BA square is equal to square of the hypotenuse is equal to sum of the square of the other two sides. So BA square is equal to BP square plus AP square. So BA we have assumed it's A square. So BP is half of BC, that is A by 2. So A by 2 the whole square is equal to AP. Plus AP square. Now I'll bring this A square by 2, A by 2 the whole square to the left hand side. So A square minus A by 2 the whole square is equal to AP square. So A square minus A square by 2 square is equal to AP square. So A square minus A square by 4 is equal to AP square. Now I'll take LCM. So A square means A by 1. So taking LCM, LCM of 1 and 4 is 4. So A square by 1 into 4 by 4 minus A square by 4 is equal to AP square. So I'll get 4A square by 4 minus A square by 4 is equal to AP square. I'll take 4 as the common factor in the denominator. So in the numerator I'll get 4A square minus A square is equal to AP square. Now this is I'll take A square common again in the numerator. A square into 4 minus 1 by 4 is equal to AP square. So A square 4 minus 1 is 3 by 4 is equal to AP square. So now AP will be equal to square root of A square into 3 by 4 is equal to AP. So this will become square root of A square is A, and square root of 3 I'll write as it is 3. Square root of 4 is 2. So this is true in any equilateral triangle. The altitude is equal to root 3 times by 2 into base or any side. Okay, so you can check root 3 by 2 times a is the side. So here, coming to the area of triangle ABC, it is equal to half base into height. Half 1 by 2, base is a and height is root 3 by 2 into a. Now here I'll cross multiply. Before that, let me simplify further. 1732 into 1 by 2 into 1 into root 3 by 2 into a. Okay, I made no changes. Now in the right hand side it becomes root 3, 2 into 2 4 into a square. So 1732.30.4. So they have given the value of, in the question they told to take root 3 as 1.73205 we should take. So I'll take that 17320.5 is equal to root 3. Okay, before that let me write write it as it is. I'll cross multiply by root 3 is equal to a square by 4. Now I'll substitute root 3 is equal to 1.73205. 17320.5 divided by 1.73205. I'll take this 4 also to the left hand side into 4 is equal to a square. So here I'll get this divided by this. I'll get 10,000. Okay, both numerator and denominator have digits same. Only we should shift the decimal places. So it is 1000 into 4. 10,000 into 4 is equal to a square. So 4,000 is it correct? It's not 10,000, it's just 1,000. 1,000 into 4 is 4,000 is equal to a square. Therefore a square will be is equal to square root of 4,000. A is equal to square root of 4,000. Therefore square root of 4,000 is 200. So 200 is equal to a. So if a is equal to 200, what is radius of the circle? It is half of that. A by 2 is nothing but radius. So this implies radius of the circle is equal to a by 2 is equal to 200 by 2, which is equal to 100. Okay, now the area of the shaded region is given by area of shaded region is equal to area of triangle ABC minus 3 times into area of the sector. All these sectors are similar to one another. Not only similar, it's congruent also. So 3 times into area of sector. What is the area of the sector? See, each sector is making an angle of 60 degree. So here 60 by 360 into pi r square. Pi they have told to take 3.14. Okay, first I'll write the okay, pi into r is 100. Just now we found r to be 100. So 3 times into area of sector. Area of sector is 360 by 360 into pi into 100. Now 0 0 will get cancelled. 6 1s are 6. 6 6 are 36. Now area of ABC, it's already given in the question itself. Area of triangle ABC is 1732.0.5 minus 3 into. So here again still further we can cancel. 3 1s are 3, 3 2s are 6. again 2 ones are 2, 2 5s are 10. So I am left with only pi into 50. Pi they are told to take as 3, how much, 3.14. I am left with 3.14 into 50. Sorry, here it's pi r square, another 100 is there, into 100. Okay, so another 100 is there. Okay, so this is 1732 minus, so this multiplication turns out to be 15700. You please do the arithmetic calculation, and finally we get answer 1620.5 centimeter square as the answer. The next question in exercise 5.3 is question number 11. On a square handkerchief, 9 circular designs, each of radius 7 cm are made. Find the area of the remaining portion of the kerchief. So there is a kerchief and there are 9 circular design in that. 1 2 3 4 5 6 7 8 9. Sorry, this like this. So 9 some kind of design is there, and the radius of each circle is how much? It is 7 centimeter. Okay, so we should find the remaining area of the remaining portion apart from the design. So this is the remaining portion, the white portion is the remaining portion, that area we need to find. So the diameter, radius of each circle is 7 centimeter, so therefore diameter will be 14 centimeter. So 14, this is 14 and this is 14, so 14 into 3 30 42. So each side is 42 centimeter. Okay, so I'll name this kerchief also A B C D. So to find the area, we should find the area of this square, that is the kerchief, and subtract 9 times the area of the circle. So this is a very simple problem. So the remaining area is given by area of the circle, sorry, area of square minus area of circle. So there are 9 circles, so I should multiply by 9. So what is the area of the square? So each side of this square is 42 centimeter. So area of square is side into side, that is 42 into 42. Now area of each circle, that is the circular design portion, that will be pi r square. So pi have they told to take it to 3.17, no, so pi, first I'll write the like this only, pi into r square. So this is 42 into 42 minus pi is 22 by 7. R, radius of each circle is 27, sorry, 7 square, and this whole into 9 times, because 9 circular design are there. So 42 into 42 minus 22 by 7 into 7 into 7 into 9. So here this 7 will get cancelled with this 7. 42 into 42, so 42 into 42, 2 2s are 4, 2 4s are 8, 10 4 8 4 8 9 10 11 12, carry 1 8 9. Is it correct? 4 2s are 8, 4 4s are 16, Okay, now 4, 8, 8, 16, carry 1, 6 plus 1, 7, 1764. So 1764 minus 22 into 7 into 9. So 22 into 7 is 2 sevens are 14, 2 sevens are 14 plus 115 into 9. So 154 into 9, 9 fours are 36, 9 fives are 45, 46 fours are 48, 9 ones are 9, 10, 11, 12, 13. So this is equal to 1764 minus 1386. So this is 14 minus 6 is 8. Then 15 minus 8, 15 minus 8 is 7. 6 minus 3 is 3. 1 minus 1, 0. So 378 centimeter square is the remaining area. Question number 12. In figure 5.30, OACB is a quadrant of circle with center O and radius 3.5 centimeter. If OD is equal to 2 centimeter, find the area of the quadrant OACB and the shaded region. So that's a quadrant. Quadrant OACB and given OD is 2 centimeter. OD is 2 centimeter and radius is 3.5, that is OB. OB is 3.5 centimeter. So first sub question is area of the quadrant. So area of quadrant OACB, this is a very simple one. Area of the quadrant is, what is the formula? Theta by 360 into pi r square is the formula. How to derive it? If you have forgotten this one, in a circle 360 degree, okay, makes an area of pi r square. Therefore theta degree makes an area of cross multiplication, theta into pi r square by 360, cross multiplication. So now substitute the value of theta. So quadrant means each quadrant will make an angle of 90 degrees. So what is a quadrant? So in a circle, if two diagonals intersect each other at an angle of 90 degree, then these two are all the parts are quadrant. Quadrant 1, quadrant 2, quadrant 3 and quadrant 4 all will be congruent. So whatever it is, one quadrant is given in the figure. So yeah, so now it is theta is 90 degree by 360 into pi is, have they given value of pi? They are not mentioned though, therefore I will take 22 by 7 into r. R is 3.5 square. So 0 0 get cancelled, 9 1s are 9, 9 4s are 36, 2 2s are 4, 2 1s are 2, 2 1s are 2. So I am left with 11 1 by 2 into 11 by 7 into 3.5 into 3.5. So one more step for simplification I can do. 7 1s are 7, 7 5s are 35. So that is 0.5 I will get. So this value turns out to be 19. 11 into 0.5 into 3.5 is 19.25. Denominator I will keep it as it is. This many centimeter square is the area of sector OACB. Now what is the area of the shaded region, right? Yeah, what is the area of the shaded region? This region area I should find. So second one, so area of the shaded region will be area of quadrant OACB minus area of triangle BOD. So this is area of shaded region. Shaded region will be equal to area of OACB minus area of triangle BOD. So what is the area of OACB? We just now found it is 19.25 by 2 minus area of BOD. This is half base into height. Half base is 3.5, height is 2 centimeter. So this is equal to 19.25 by 2 minus, so 3.5 into 2 is 7.0 by 2. Now if I take 2 common factor in the denominator, it's 19.25 minus 7.0. So I will get 12.25 by 2. So let us check the answer. So in answer exercise 5.3 answer question number 12, so they are given 77 by 8. So 77 by 8, see 77 by 8, it turns out to be 9.625. okay, this 19.25 by 2 also turns out to be 9.625. okay, this many centimeter square. So you don't have to worry, this is correct answer. And in the second sub question answer they are given 49 by 8. So 49 by 8 also 49 by 8, it turns out to be 6.125. So here 12 in the second answer 12.25 by 2 also is 6.25, this many centimeter square. So you can leave the answer in the fraction itself, that is in the first answer 19.25 by 2, in the second answer 12.25 by 2. At this point only you can end this exercise 5.3 question number 13. So in figure 5.31 a square OA BC is inscribed in a quadrant OP BQ. If OA is equal to 20 centimeter, find the area of the shaded region. So there is a quadrant and a square is inscribed in it. This way, quadrant is OPBQ and the square is OABC, and given that OA is equal to 20 centimeter. Find the area of the shaded region. So this shaded region we should find the area. So what is the quadrant? As I told you, in a circle, if two diagonals intersect each other at an angle of 90 degree, then 4 quadrants will be formed. 1, 2, 3, 4. So in one of the quadrant they have inscribed a square of length 20, how much is this, 20 centimeter in length. So what is the area of the shaded region? It's very simple. Area of shaded region will be equal to area of quadrant minus area of the square. So area of quadrant OPBQ minus area of square OABC. Now what is the area of the quadrant? So each quadrant makes an angle of 90 degree. So what is the quadrant is also a sector. So now what is the formula for the area of the sector? It's given by theta by 360 into pi r square, right? So area of the quadrant is 90 by 360 because it's making an angle of 90 degree. So into pi have they told, okay, they have told to use 3.14. into R. What is the radius? Radius we don't know. Okay, we don't know the radius, so I'll take it as R square minus area of square OABC. So area of the square OABC is side into side, that is 20 into 20. So I actually forgot to find the radius. Radius is very simple to find. Now you can see, now I will join OB. Okay, now OAB is a right angle triangle. Okay, in triangle OAB, angle A is equal to 90 degree. Since this is a square, all angles will be equal to 90 degree. So hypotenuse square is the Pythagoras theorem. Hypotenuse is OB. So hypotenuse square is equal to sum of the square of the other two sides, that is OA square plus AB square. So what is OA? OA is 20, so 20 square. What is AB? AB is also 20. 20 square plus 20 square. So this is 2 2s are 4, 400 plus 400. So I'll get 800. So OB square is equal to 800. Therefore, if I take the square root of both the sides, square root of OB square is equal to square root of 800. The square root and this 2 will get cancelled. OB is equal to square root of 800. So OB is nothing but the radius. Okay, I'll put the radius value here, coming to the solution here. So 90 by 360 into 3.14 into, so R square. So R is square root of 800, or R is equal to, okay, R is square root of 800 the whole square minus 20 into 20. Now here I'll simplify. 0 0 will get cancelled. 9 1s are 9, 9 4s are 36. Okay, so I'm left with 1 by 4 into 3.14. So square root of 800 the whole square is just 800. That power and root will get cancelled, so I'll get only 800. So minus 20 to 20 is 2 2s are 4, 00. Now 4 1s are 4, 4 2s are 4, sorry, 4 4s are, oh sorry, 4 2s are 8, 00. So I'm left with 3.14. 3.14 into 200 minus 400. So here 2 8s are, sorry, 2 4s are 8, 2 1s are 2, 2 3s are 6, 00 will come, and decimal after 2 place. So 628 minus 400. So 628.00 is nothing but 628 only, minus 400. So this is 8, 2 minus 0 is 0, 6 minus 4 is 2. Oh sorry, 2 minus 2, 2 minus 0 is 2, and then 6 minus 4 is 2. 228 centimeter square is the area of the shaded region. Next question here in this exercise 5.3 is question number 14. AB and CD are respectively arcs of two concentric circles of radii 21 centimeter and 7 centimeter and center O. If angle OAB is equal to 30 degree, find the area of the shaded region. So this shaded region, I should find what's the area of this shaded region. So now see, it's given that CD and AB are the arcs, okay, arcs of two concentric circle. So circles it is not shown, so circle will be like this, something like this, And now OCD, OC, I'll call, okay, OCED. OCED is the sector of smaller circle, and there is a another circle also which is not shown. It is not necessary to draw this, but for your reference I am showing it. Now OA, OAFB is the sector of the bigger circle. Okay, now what is the area of the shaded region? So area of the shaded region will be the difference between the area of these two sectors. Okay, I'll write area of shaded region is equal to area of sector OAFB. OAFB is the sector of the bigger circle. Okay, I'll take that area and I'll subtract with area of sector OCED. If I subtract, I'll get the area of the shaded part. Okay, now what is the formula for sector? It is theta by 360 into pi r square. So how to derive it? Very simple. In a circle, 360 degree makes an area of pi r square. Therefore, theta degree makes, just cross multiply theta into pi r square by 360. So if you can't remember this formula, you can just derive it. So now what is the area of the sector OAFB? Should we take okay, theta it is given that it is 30 degree. So 30 by 360 into pi we should take 22 by 7. It's not mentioned to take 3.17. So pi by default it will be 22 by 7. So and r square, r radius of the bigger circle is 21. So 21 square minus area of this smaller sector, that is 30 by 360 into 22 by 7, that is pi, into r square. Here area of the small circle is 7, so 7 square. Now 30 by 360 into 22 by 7 is common in both, so I will take that outside. 30 by 360 into 22 by 7, this is common, so then 21 square minus 7 square is left out. So now you can simplify here. 0 0 will get cancelled. 3 1s are 3, 3 12s are 36, then 2 6 are 12, 2 1s are 2, 2 1s are 2. So I am left with 1 by 6 into 11 by 7. Now 21 square, so 21 into 21 is 21, and 2 1s are 2, 2 2s are 4. So 1 4 4 441, 441 minus 7 square is 49. So how much? 1 by 6 into 11 by 7 into 441 minus 49, 441 minus 49. So 10 minus 9 is, sorry, 11 minus 9 is 2. Then 13 minus 4, 13 minus 4 is 6 7 8 9, so 392. So into 392, now this is divisible by 2, 2 3s are 6, 2 1s are 2, 2 9s are 18, 2 6 are 12. Again, is it divisible by 3? Now this 196 is divisible by 7, 7 1s are 7, 7 2 7 2s are 14, then 7 5s are 35 7 6 are 42, 7 7 are 14, 7 8 are 56. Okay, now I'm left with 11 into 28 by 3. So 28 into 11, 28, 28, so 8, 8, 9, 10, carry 1, 3. So 308 by 3 centimeter square is the answer. This circle did not come properly. Now I think you can see it. Question number 15. In figure 5.33, ABC is a quadrant of circle of radius 14 centimeter and a semicircle is drawn with BC as diameter. Find the area of the shaded region. So given that the radius of the circle is 14 centimeter, that means AC is 14 centimeter and AB also is 14 centimeter. Now I should find the area of the shaded region. So before finding the area of the shaded region, I will find the area of segment BEC. Okay, I will name this as B and this as D. Okay, so BEC is the segment of the circle centered at A, sorry. Okay, I'm drawing this for your reference. Now what is the area of the segment BEC? So this is the area which I am finding out. So area of segment BEC is given by area of quadrant ABC, area of quadrant ABC minus area of triangle ABC. Okay, now what is the area of the quadrant here? So quadrant, it is making an angle of 90 degree, therefore use the formula theta by 360. What is the area of the quadrant? That is theta by 360 into pi r square. How to derive it? 360 degree makes an area of pi r square, therefore theta degree makes an area of cross multiply theta into pi r square by 360. It's very simple to derive. Even if you don't remember, you can derive within 10 seconds. Now what is the area of the quadrant ABC? So quadrant, it is making an angle of 90 degree. So 90 by 360 into pi is 22 by 7 into r square. So r, that is r is 14. Okay, 14 square minus what is the area of triangle ABC? That is half base into height. Half base is 14 and height is also 14. So here simplify, 0 0 will get cancelled, 9 1s are 9, 9 4s are 36. Okay, then 2 2s are 4, 2 1s are 2, 2 1s are 2. So I am left with 1 by 2 into 11 by 7 into 14 square is 14 into 14, 14 into 14 minus 1 by 2 into 14 into 14. Now here you can take 1 by 2 into 14 is common, and the remaining is 11 by 7 minus here 1 is left. I am just taking 1 by 2 into 14 as common. Okay, now 1 by 2 into 14. Now here LCM of 1 means 1 by 1. So now LCM is 7, LCM of 1 and 7 is 7, therefore into 7 divided by 1 into 7. So 1 by 2 into 14 into 14 into, so this becomes 11 by 7 into 7 by 7. Again this 1 by 2 into 14 into 14. So 7 is common in the denominator. So 11, sorry, this is minus. So 11 minus 7. So now here this 7 will get cancelled. 7 1s are 7, 7 2s are 14. 2 1s are 2, 2 7s are 14. So I am left with 7 into 2 into 11 minus 7 is how much? 4. Okay. Now 4 2s are 8, 8 7s are 56. 56 square. The measurement are in a centimeter, right? Okay. Therefore, it is 56 square centimeter. Okay. This is the area of the segment BEC. Now, what is the area of the shaded region that they have asked in the question? So, area of the shaded region. Area of the shaded region. So you can see that let the midpoint of BC be O. Now OBDC is a sector. OBDC is also a semicircle. Semicircle is also a sector. See, what is a sector? Sector is a part formed by two radius and an arc, right? This is a sector. Okay. And sector can be like this also. From center there is two radius like this and arc like this. This is nothing but the semicircle. Semicircle is formed by two radius and an arc. So this is also a sector. Now the area of the shaded region is given by area of semicircle minus area of segment BEC. Okay, this one. Area of segment BEC is 56 square centimeter. Just now we found out. Now what is the area of the semicircle? So area of the semicircle is, so here semicircle is making an angle of 180 degree, right? So this is the 180 degree angle. So 180 by 360 into pi. Pi is 22 by 7 and radius. Now what is the radius? Radius we still don't know. I will just mark it as r square minus area of segment BEC is 56 centimeter square. Now to find the radius in the semicircle OBDC, now in triangle ABC, BC is the hypotenuse. Okay, so I am writing here in triangle ABC. Okay, A is a right angle, therefore square of the hypotenuse is equal to sum of the square of the other two sides. Therefore BC square is equal to AB square plus BC square. So AB is 14. So 14 square plus 14 square. So what is 14 square? 14 square is 196 plus 196 is BC square. So add these two. 6 6 12, carry 1, 9 9 18 plus 1 19, carry 1 1 2 3. So 392. BC is equal, BC square is equal to 392, or BC is equal to square root of 392. Okay, so BC is 392. So what is OC? Half of that. OC or BO is equal to radius is equal to half of BC, that is 392 by 2. So that radius I'll substitute here. Now coming to this solution, so 180 by 360 into 22 by 7, R is root of 392 by 2 minus 56. So root of 392 the whole square. Okay, now simplify this. 0 0 will get cancelled. 18 1s are 18, 18 2s are 36, 2 1s are 2, 2 1s are 2, 2 1s are 2. So I am left with 11 by 7 into, so now square root of 392 by 2 is, in the numerator square root symbol will go, 392 will be there, minus numerator 2 square is 4. Okay, square root of 392 by 2 the whole square is 392 by 4 minus 56. So this is equal to, I am writing once again, 11 by 7 into 392 by 4 minus 56. Now this 392 is it divisible by 7? 7 1s are 7, 7 5s are 45, 7 4s are, what is 7 4s are, oh sorry, it goes in 7 5s are 35, and 7 4 is left, 7 6 are 42. Now is it divisible again from 4? 4 1s are 4, 4 4s are 16. Yeah, divisible by 4. 4 1s are 4, 4 1s are 4, 4 4s are 16. So I am left with 11 into 16 minus 56. So 16 into 11, how much is 16 into 11? 16 into 11, 16 6 6 7, 176, getting 170. Oh sorry, this is 4 1 4. So 11 into 11 into 14 minus 56. So 11 into 14 is 154. 154 minus 56. So finally we will get answer 98 centimeter square. So area of the shaded region is 98 centimeter square. The last question in this exercise and in this chapter is question number 14. Calculate the area of the designed region in figure 5.34, common between two quadrants of circle of radius 8 centimeter each. So two quadrants. See, there are two quadrants here. I'll complete this circle here. It's like this. Now let this be O, OA, OAB. OABC is a OADC is a quadrant. Okay, now there is another quadrant here. I'll complete this circle here. So another quadrant, FA, FAGC is another quadrant. There are two quadrants. Okay. Now I should find the area of the shaded region. This area I should find. Now given the radius is 8 centimeter. Okay. Now I'll join AC. Now what is the area of segment? Area of segment ADC. See, ADC is a segment of the circle centered at O. So this area is given by area of the area of quadrant OADC minus area of this triangle minus area of triangle OAC. So what is the area of the quadrant? This quadrant, it is making an angle of 90 degree. Therefore area will be, what is the formula? Theta by 360 into pi r square is the area of a sector. So now this quadrant is a sector making an angle of 90 degree. So 90 by 360 into, so pi is they told to take pi 3.17. No, so they have not told. So default is 22 by 7. So into r is 8. So 8 square. Now what is the area of triangle OAC? Area of triangle OAC is half base into height. Base is OC into height is OA. So 90 by 360 into 22 by 7 into 8 into 8 minus 1 by 2 into, what is OC? OC is 8. OA is also 8. So now I will simplify. 0 will get cancelled. 9 1s are 1, 9 4s are 36, 2 2s are 4, 2 1s are 2, 2 1s are 2. So I am left with 1 by 2 into 11 by 7 into 8 into 8 minus 1 by 2 into 8 into 8. Now I will take 1 by 2 into 8 into 8, that is common between the first term and the second term. Okay, so this I will take common. So the remaining is 11 by 7 minus 1. So 1 by 2 into 8 into 8. So here LCM is of 1 is 1 means 1 by 1. So 11 by 7 minus so LCM is 7. So 1 by 1 into 7 by 7. I'll get like this. So 1 by 2 into 8 into 8. So 11 by 7 minus, now I'll take 7 as common. So 11 minus 7 is left in the numerator. Now this is equal to 1 by 2 into 8 into 8 into 11 minus 7 is 4 by 7. Now 2 1s are 2, 2 2s are 4. Now 8 8s are 64. 64 into 2, how much? 128. So 128 by 7 centimeter square is the area of the segment ADC. Okay. Now what is the area of the segment AGC of circle centered at F? Okay. Similarly, area of segment AGC of circle centered at F will be equal to 128 by 7 centimeter. Okay, both these segments are similar and congruent. Okay, now the total area will be the sum of these two segments. Okay, therefore total area is equal to sum of areas of segments, sum of area of segments ADC and segment AGC. So this is equal to 128 by 7 plus 128 by 7. So 7 is common. So 128 plus 128, 256. So 256 by 7 centimeter square is the answer. This is the area of the shaded region shown in the figure. Summary of this chapter. This chapter has got very less number of formulae. It's very easy to remember. So first is the circumference of the circle. Circumference is given by C is equal to 2 pi r. So circumference is nothing but the perimeter or the length of the curved edge. This length is given by C, that is circumference. So C is equal to 2 pi r. So 2r is d. Okay, therefore C is also given by pi d. The next point is area. Area of the circle is given by pi r square. Area is equal to pi r square. And next point is the length of an arc of a sector of a circle with radius r and angle with degree measure theta is given by theta by 360 into 2 pi r. So arc length of a sector is equal to theta by 360 into 2 pi r. So what is the arc length? So you know that a circle gives perimeter of 2 pi r. Okay, so this length is circumference or 2 pi r, and if this is the sector, what is just this is the arc length of this sector. Okay, say this sector makes an angle of theta. So what is this arc length? This arc length is given by theta by 360 into 2 pi r. So even if you forget, it's very easy to remember. So 360 degree gives an arc length of 2 pi r. So therefore theta gives an arc length of cross multiplication here, theta into 2 pi r by 360. So similar to this formula, what is the area of the sector? Area of sector of an circle. So if this is the circle and if there is a sector making an angle of theta degree, so what is this area? This area is given by theta by 360 into pi r square. So if you forget formula, how to derive it? Okay, 360 degree gives an area of pi r square. Therefore theta gives an area of, here also simple cross multiplication, theta into pi r square by 360. And the next point is area of a segment of a circle. So what is a segment of a circle? So what is AB here? AB is a chord. So AB chord makes an subtends an angle of theta at the center, let us say. So what is the area of ACB? ACB is a segment. Okay, now area of segment area of segment ACB is given by area of sector OACB. So OACB is a sector here in this circle, minus area of triangle OAB. OAB gives the area of segment ACB. This is the segment ACB. Okay, and that completes this chapter.